All right, guys, I got something a little special for you today. We're going to be tearing down a 7.5 ton Copeland semi-hermetic compressor. Big shout out to Mr. John McMasters for donating this compressor to me. Now, this compressor apparently wasn't pumping and it was shaking really, really bad. I have an idea what the problem was, but I figure what the hell. Let's tear it down and see what's going on inside, all right? Let's get to work. All right, guys, let's get started. First thing I want to do is I want to take off this electrical box and see what's in there. Now, to some degree, this compressor has already been dismantled. When they replaced it, they also took it apart to see what was wrong with it. I believe they did try to make some repairs to it. I believe the valve plate was replaced, but beyond that, I really don't know. All right, well, let's disconnect our motor windings here. There's our terminal block. Interesting. Man, that is a big old chunk of steel right there, bud. Now, if you were doing this in the field, obviously make sure you mark your wires. This compressor will never run again. Not on my watch, anyway. I'm not going to take it back for a core charge. I'm going to put it on my desk as a paperweight. Oh, right there. This must be our thermal limit. Interesting. It says right here, do not remove. So you guys better not tell anybody I removed this. But let's just keep that out of there. Next, let's take off this valve plate. See. Not terrible. Not broken. Not cracked or anything like that. If you look right down in there, you can see some part of the piston anyway. It looks like the wrist pin maybe is still connected down there. Let's see if we can get this valve plate apart here. Oil doesn't look good. Looks like it's overheated a little bit. A little bit of residue, metal shavings. Obviously, from when that piston broke down on us. All right, let's take off this pump assembly. Interesting little pump assembly here. Well, let's take that apart. You hear something sloshing around in there. Now I got to know what the inside of that looks like. Interesting. Almost like a, I don't want to say a rotary pump, but as this star sprocket here spins around, it looks like it just pushes oil down through these little holes right down there, right down there. Sure is a fancy little design. Surprised how easily this thing comes apart. All right, let's put this guy back on there. Let's set him aside for a little while. Then a gentle little tap. There. Bearing looks pretty good. Not terrible. Yeah, so we got just the one moving. Now, when you have just one piston left inside one of these things, it's going to shake around because it's out of balance, obviously. Come on, get off there. Right here we got our ginormous windings. And a bolt that connects our crankshaft. All right. Good old M18 Milwaukee got her. All right, guys. Well, I'm going to start the process of flipping this thing over so we can take the bottom off, all right? Yeah, she broke. All right, here's a, looks to be a strainer of some sort. Not real sure what this connects to. Probably, if I had to guess, the oil return. Let's see what else we can dig out of here. There's a shattered piston right there. So I'm going to go out on a limb and say this thing had some floodback issues. And that is what exploded the pistons. Look at that. All sorts of little chunks and bits down inside here. Must be the wrist pin or some part of the bottom of the piston. Well, let's see if we can't get these pistons off here. Let's rotate this guy back around. Looks like we're stuck on some broken piston stuff. Some more chunks of pistons. I don't have the right tool for that. Well, I tried everything I know. Doesn't appear that crankshaft is moving at all. We're getting there. Well, she's moving. Not very fast. There she went. Hey, look at that. Our compressor just gave birth to a crankshaft. And right over here, we got this giant ass stator. That is a chunk of steel, man. Look at that thing. Holy crap. This thing alone must weigh 25 pounds. Just gonna pull our piston rings off here so I can see if I can get this piston out. There is our one and only good piston. Interesting. Well, guys, I don't know about you, but I thoroughly enjoyed myself. All right, well, there we have it. That's all of it, guys. Well, guys, I hope that was fun for you because it was fun for me. So now, next time you work on one of these, you'll have maybe a little bit better understanding of how they come apart, what they're made out of, and things that can possibly go wrong with them. All right? Thanks for watching. See you next time. All right, 50 degrees. There's our low profile coil. It feels much colder than 50 degrees in here. Coil's not froze up. Let's go over here. I wonder what this thermostat says. All right, so both thermostats say 50. I guess my internal thermostat is off. So coil's clear. I'm gonna get a flashlight and check the inside of the coil, make sure we're not plugged up, but I think our next step's gonna be to get up on the roof, see what's going on. As you can tell, we're up on the roof now. This is the condensing unit to that walk-in cooler. Our model and serial number information. I have been here before. I can't really remember why. It's been a little while. See? That's how I know. It's been a little while because of the fading on my sticker. That's how I tell how long I've been at a place. How long ago I've been at a place. Anyway, all kidding aside, let's see what we got going on here. My initial inspection, we got a little bit of water underneath our suction line. We have nothing going on. Our disconnect is on. So first things first, I'm going to pop this panel right over here, and we'll check for some voltages. Now, since everything's dead, I'm assuming we're off on low pressure. Now, why we're off on low pressure, I'm not real sure yet. So first thing, I'm going to check for incoming power at my contactor, and then I'm going to pull the cover off of my low pressure switch and see if that's open or closed. And depending on if that's open or closed, I may go back downstairs, check my thermostat and our liquid line solenoid, as well as airflow. But first things first, we'll check incoming power. All right, guys, let's check for incoming power. L1 to L2, 210, L1 to L3, 210, L2 to L3, 210, L1, L3, again, 210. All right, so we do have proper incoming power. It's 0 volts going across our contactor. It is a 208 contactor, 208 coil contactor anyway. So that's why it's not pulled in. All right, guys, well, I don't have proper voltage going to my contactor, so let's check our pressure switch. Let's see, 0 volts. Let's go right across here. We got 208. Now, I should read 0 if it's closed, but it's not closed, so we got to figure out why it's not closed. And real quick, let me throw a jumper on there. Really, really quick, let's just show you what I'm talking about here. See? So our pressure switch is open. Let's figure out why. Now, let's think about this. Just because our pressure switch is open doesn't necessarily mean we have a leak or we're out of refrigerant. We could have a problem with our thermostat. We could just be in pump down. We don't know that. So we're gonna hook up to our line set and see if we're flat, or see if we're in pump down, or see what's going on. There, let's get that glare out of there. All right, well, it looks like we may be just sitting in pump down mode. Our low side is about 6 psi, high side 148, 149 psi. So I think our next step is to go downstairs and check power at that thermostat and our liquid line solenoid. All right, guys, there's our thermostat. There's our meter. Let's see what we get here. .208 going across it, which I shouldn't have. I should have 0 because it should be closed, obviously, but it's not closed. So our return air temperature leveled out at about 51 degrees, which means our wall thermometers are pretty accurate, which also means that this mechanical thermostat is bad. Turn it way down to -20. We still got nothing. No click, no snap, no nothing. Oh, that's weird. I turn it up to 50, it comes on though. Looks like it just closed again. Yeah. Bizarre. Interesting. Let's check something real quick here. So we go over here to our solenoid. It's still open. Or rather, I mean, our thermostat is still open. Hasn't sent power to our solenoid, so our solenoid isn't energized. So real quick, I'm just gonna throw a jumper on here just to sort of show you guys what should be happening versus what is actually happening. I'm trying to do this one-handed. Let's see if I can do this without shorting anything out. Alright, now you can hear the solenoid energize. You can hear the refrigerant going through our metering device, through our distributor. Let's give it a second, see if we can see any frost building up on that distributor right there. Yeah, if you go look on the end of our distributor, you can start to see frost. You see it slowly creeping down the distribution lines. So our thermostat is definitely faulty. I'm gonna go grab one out of my truck and we will replace it. Don't mind the mess, guys. This rag right here, it's out of place. That's my mess. This cart right here, got this because I got a bad back, and it really helps to haul compressors, nitrogen tanks, all that stuff through buildings rather than have to carry it. Anyway, right behind here, I think I got what we need. Yeah, right here. A19, ABC, blah, blah, blah. Cool. Let's go get this bad boy installed, alright? Well, I just restored power, and now one of my fan motors doesn't want to start for some reason, which is really, really stupid. So, let me see what's going on with that now. So those fans are going right. Keep in mind our airflow. These fans suck in and they push it out the sides. Simple problems, not so simple solutions. It's not terrible, but... So our evaporator fan motors failed, right? And I was thinking that I could just take the screws out of these, the ends of these brackets, or the end of this bracket right here, and then I could just lift it up and pop it out. But what I found out is this chase that you see right back here that houses the wiring, there's a screw that goes through the chase right there, it'll focus, into the evaporator fan bracket itself. So I have to get to the top side of this chase to take that screw out and also to access the wiring, which means I have to flop this evaporator cover over, which isn't terrible, just kind of a pain. I was hoping I could be a little bit less invasive about it, but it is what it is. Luckily I got a union right here, so pop that off, flop this over, get access to the wiring, and we'll call it good. Alright guys, got my evaporator cover pulled down, got the new motor mounted. I'm just going to wire nut it. I'm going to keep this little Molex piece here and just, wire nut it in there. I'm doing this, you're probably wondering why I don't just cut this Molex, this molded plug right out of there and just wire nut it directly. I'm doing it this way just in case somebody ever wants to replace it with the original, the OEM motor. And then this way we still have the Molex here, because what I'm replacing it with is just a Mars universal motor. So that's my reasoning behind it. Also guys, when you're pulling these down, they do get kind of heavy, they're awkward, so leave that center nut right there, leave that one in place when you're pulling it down, so you can just get the two outer sides done, leave that center one, and then this way you can lower it down a little bit easier by yourself. So let me get this wired up, I'll get it remounted, and then we'll power it on and see if we have any luck. Alright guys, I'm going to take a quick second and call myself out on something. Don't be an idiot, alright? Before you install a fan motor, double check the rotation. The original fan motors are counterclockwise. The one I put in, of course, is clockwise. So I had to run up to a local supply house real quick and grab one. No huge deal, just a waste of time that I cannot bill my customer for. So don't do like me, all right? Unless it's something good that I did, then do like me. But if it's installing the wrong motor, don't do that. Double check stuff, all right? It pays. Pay attention, little details, all right? New fan motor's installed. New thermostat is in. We are up and running. We're looking pretty good. 35-degree evaporator. It's almost 60 degrees in that box, so we are under a pretty high load right now, so that's why our evaporator temperature is so high. Condensing temperature, not bad. A little bit higher than normal, but again, we're pulling out a lot of heat right now. It's probably 75-ish degrees out here, so we're not too far off. Not sure if you guys can even see the screen on this. But yeah, so far so good. I'm gonna let it run for a little while and see if we can start bringing that temperature inside that box down. Well, no idea what's going on now. System just pumped down for some ungodly reason. So now we gotta go back downstairs and investigate again. All right, again, we are back up and running. I'm not real sure what happened, but either I bumped the thermostat when I was putting that fan in, or somebody moved the thermostat, but the thermostat magically went up to 50 degrees. That's why it pumped down. So I adjusted it back down to 36, and we are up and running again. One of those days where a lot of stupid little things are happening. All right, guys, let me let you go for now. Let this thing cool down for a bit, and I'll bring it back around when I'm all set. 35.6. Looks like we are all set tonight. Thanks for sticking around, guys. We'll see you on the next one. Hey, what's up, YouTube? Curious HVAC guy here. And today it's Sunday, about 10 o'clock in the morning, and I was a little bit bored, so I slammed a cup of coffee, came out here in my shop and see what I could do. And I've decided that today I'm going to be tearing apart this little vacuum pump here. It's a little JB6CFM vacuum pump. Now this pump came off of one of my guys' trucks. It's been decommissioned, essentially. It sort of kind of worked.
It's beat up, it's missing its base, doesn't do very well, and I don't really want to spend the money to have it rebuilt. It's my pump, so I'm going to do with it what I want. And what I want to do with it is tear it apart and see what's inside. So let's get after it. First thing we'll do is take off the front of this. I've already drained out as much of the oil as I can. There'll probably be a little bit oil that'll come out, but shouldn't be much. Hopefully it shouldn't be much. Screws underneath here. Hammer time. Very nice. A lot more oil than I thought. All right, we're back. I just had to take a few seconds and clean up my little mess there. So let's see what we got going on in here. I'm not sure what this plate is. Some sort of protective covering maybe. Well, let's get that out of there. All right, so it looks like some sort of little tiny reed right here. This would be where it discharges our gas or refrigerant, whatever it's sucking up. So screw right there. Just sort of stuck in there with a thick film of oil. There we go. Yeah, so this is our discharge reed right here. So this, since it has this top piece right here, I'm assuming this is going to be our discharge reed. So what happens as it compresses and pushes the gas or whatever it's sucking out of it, this little reed will come up, and this piece right here is designed to keep this from like overextending, from just blowing itself out, just bending itself in half. Sort of like this. If that wasn't there, it would just blow up like this, blow up like that every single time, and then eventually it wouldn't work. Like it doesn't work now. Let's get that out of here. This other one right here in front too. Again, guys, I'm not a vacuum pump specialist. I have a vague understanding of what's inside, so there's probably somebody out there watching that knows better than I do right now. If you do, shoot me some comments. I'm okay with it. Yeah, down inside here, looks like we have another reed. Another tiny little reed plate. Interesting. This looks like it simply disconnects our pump section from our motor section somehow. here is something. Maybe get this apart so I can get to the insides. Maybe something like that. Oh, sure. Now, obviously, guys, I could have read up on this and pretended to be some sort of vacuum pump genius when I made this video, but it really wouldn't be fair because I would sort of be lying to you guys and pretending like I am some sort of vacuum pump genius when I'm really not. I'm literally only doing this because I'm curious to see what's inside. Now I've seen them made some sort of puzzle out of it. Well, when all else fails, hit it with a hammer. I can't seem to get this pump part, I guess you will, to separate from the shaft. Is there one bolt that just doesn't want to come loose? There we go. There's our little motor here. Got your on-off switch, capacitor. Oh, never knew there was just a simple little plastic spline connector. It looks like we have a little Allen screw in there. All right. Well, but there is a little burr that's stuck on the shaft. So I'm really just going to destroy it just to get it off here. All right. Well, put up a little bit of a fight, but we got her. Take a second to clean up my freaking mess here. Alright guys, got my mess cleaned up. Also had to wait for the train to go by because I live right next to a train track and it's super annoying sometimes. So we have our, what I assume is our pump assembly, which is now more like a puzzle piece than anything else. Very slippery. Yes, it's a rotary pump. Yeah, interesting. Well, that is pretty cool. Let's see if I can put this sorted together for you guys. So if you look at this, these little, I guess, slats of metal, I'm sure they have a technical term for them, but I don't know what they are. Because again, I'm not a vacuum pump specialist, so I'm just curious about what's inside of things. So as this motor turns, and again, this is where our motor would be on this side. So we're getting sort of an inside view. So now this is just how it would be inside the machine. We connect right into there, our motor's spinning. These things kick out by what I assume centrifugal force. So our vacuum port right back here sucking in through this into the back side of this, which is right here. And this, again, I believe is spinning so fast that centrifugal force is going to kick these out, create that seal around this outer edge, and then push it out the front like this. And then once it comes out the front, it's going to come up through the top here, this hole right here, and it's going to go through there into our handle and exit the machine. That's what I think's going on here. Alright guys, thanks for hanging out with me for a few minutes anyway. Hope you enjoyed the video. Hope you got something out of it. Again, I'm not a vacuum pump specialist, so I don't know all the terminology for any of this crap. But if you do, shoot me an email so I'm a little bit smarter. Alright? Put the email right down here, alright guys? Thanks for watching. See you on the next one. Alright guys, this is what we're doing today. Alto Sham. We are replacing this manifold right there. When they're cooking product in here, yeah, I know it's dirty. I interrupted them right in the middle of using it, so it's not clean because of me. Anyway, when they're cooking product in here, they put the probe in the product and they plug the probe into these manifolds. And that's how the unit knows how hot the product is, what the internal temperature of it is, and when to stop cooking it. So we have a retrofit kit that we're going to be installing today. Potted manifold retrofit kit. And this kit comes with a new manifold, new rubber grommet, some new screws, food grade silicone, and this handy dandy how-to guide. Now, just for presentation purposes, I'm going to follow this how-to guide step by step. I'll put a little picture up in the upper left-hand corner of each little section. It's a fairly simple install. Once you've done one, it's very, very easy. So start there, right? Obviously, it's unplugged because it's sitting on a table in the dining room. So pull this top panel off, and we'll get started. Alright, next step, we need to remove this plug, J4, and the one right back here, J6. Simple enough. And these two go right down to our manifold here. There we go. I already cut my zip ties. Step 5, step 6 is to dig out all this caulk. So make sure you bring a razor knife because you're going to need it. Alright, so all the caulk has been removed. That means we can successfully drop our manifold down and pull these plugs through this little hole. Alright. Gonna need a 7mm socket. Alright, there's our manifold, and normally you'll have to cut some of this old caulk out of there, but yeah, it's not the case on this one, so we're going to be skipping that step. And then we just pull our wires through this little hole. And now we put the new one in. Alright guys, so it looks like this hole has been opened up before, so I don't need to do that today, which also means there's no sleeve to remove as well, as we see in step number 11. So we're going to move on to 13 and 14 right now. And I install this, which I already split. Just like so. And then we need to put a bead of silicone just along the front edge of this, and then we can put it in place. Alright, silicone's in place, and again, it only goes on the front, right above our ports. Now, let's put it on. Alright, so step number 15 and 16 We're going to plug these wires back into this terminal, and we're going to plug them back into the board. Pretty simple. You notice the plug, you can really only go on one way, so if you screw it up, you shouldn't do this. You shouldn't be in this business. Alright guys, we are finished. As you can tell, put a nice mound of caulk over top of that grommet. Again, it's not in the manual, but this oven cavity gets very, very hot. Very, very steamy. So that little bit of caulk, in my opinion, is going to do more good than harm. So anyway, all we got to do is put the top back on. Manifold's in place. Looks good. And then we'll wheel it into the back and plug it in. Good to go. Hey, what's up everybody? So today we have this train unit here that doesn't want to heat for us. It's currently 30-ish degrees outside, and the back of the house at this restaurant is about 55, 56 degrees. So I just got up on the roof and sort of just verified I have a blinky light on my RTRM board. You'll notice our transformer there, it's on the 230 tap. I'll bet you that's wrong, so we'll have to change that. This right here, 99% sure that is our wireless sensor, our thermostat system. So we'll verify a call for W1 in just a second, but first we're just going to go through a couple little visuals. Let's see, blower's working. Yeah, belt looks a little floppy, might have to adjust that. Let's see, that motor looks like garbage, bro. Nothing jumping out at me here. Other than this motor looks like it's been pretty hot at one point in time. Igniter back there, or our flame sensor rather. It's pretty bad. Nice and rusted up. I'll probably end up replacing that along with our sparker. So, first things first. Let's check out these blinky lights. So we got 6 blinky lights. 6 blinky lights means flame rollout is open. Well, that's no good, is it? Alright, so before I just go ahead willy-nilly and resetting our flame rollout, that little guy up there, let's double check our heat exchanger. Because you never know. This unit's not that old, but you just never know. Alright guys, here's our heat exchanger. Now, I know it looks fairly bad, and it is, But the majority of this I've scraped all along these seams with the screwdriver. I don't have any soft spots. I don't have any openings. There's no visible cracks. Like I said, there's no weak spots. My only area of concern is way up front where I can't see. And I can't really disassemble the entire machine to see the front of the heat exchanger. At that point, I might as well just quote to replace it. Because, I mean, you're talking pulling the blower out, the motor. I mean, just to get up there into the front. But from what I can see back here, there's no openings or anything like that. So we're going to reset this, fire it up, and see if I do actually have rollout or if I just have a failed rollout switch. Let's reset our little rollout switch right here very carefully. You should probably do this. Well, that's dead. Let's power that off instead of just staring at it. Alright guys, there's our noisy inducer motor. I do have 212 volts going to it in my blue and my red, which is my black and my red. We'll double check over here. So high fire. There we go. Anyway, we got voltage to it. It's not turning. We need a new one. Get out of there. Jeez, bro. This is what I'll end up doing is quoting also, along with the inducer, a new flame rod, new igniter. Pressure switch looks okay. Tubing's not dry rotted. That looks okay. What I assume happened since our rollout switch was tripped, I'll bet that it was in heat mode and all of a sudden our inducer just died. And maybe our pressure switch didn't cut out the valve, didn't shut the valve off instantaneously, or maybe the inducer was just moving slow enough to the point where some of the flames started coming back. But I'm not 100% sure on that. I'm going to recommend they do replace that heat exchanger anyway, just based on its looks. No visible cracks. Nothing I can prove, but, you know. Alright guys, let me make some phone calls and see what the owner wants me to do. And we're back, guys. We are going to be replacing this inducer motor. Blam. Got the new one right here. Voltage looks correct. Purple, pink, black wires looks correct. The customer only approved me to replace the inducer motor, not the other things that I recommended that they replace, just based on age. Now, of course, since the inducer was bad, I couldn't safely check everything else, so I didn't. So once I get the inducer motor in, as I told the customer, then I will be able to verify the other components. So they're well aware of this. So let's get to work. So, right back there, it's always the last one I've noticed. It's never the first one. It's always the last one. But that one is rusted to the point where the square sides of it are rounded out. So I'm gonna have to get a little bit creative to figure out a way to get that thing out of there. Now, it's a good thing that I'm a fairly calm person, because if I wasn't, I would have kicked a hole right through this rooftop unit. But I am staying pretty calm despite this one little bolt that was rusted out to the point that I couldn't turn it. Does not want to release. So I drilled a hole through it, ruined a drill bit, used another drill bit, got a hole through there, and then for no reason, my fancy little tripod top part snapped off, which is real stupid. So, all the more reason to dislike Train. Thanks for breaking my tripod, Train. Alright, let me throw some more tools at this thing. If I would have just brought my Dremel tool, it would have been simple. I would have just zipped it right off, but yeah, I don't have it today, and it's not really at a good enough angle I can get my angle grinder in there and do anything with. I mean, there's not enough room back there to properly, safely work an angle grinder, so we'll get it. It's just going to take me a bit. Finally got that bolt out. Wiggle this thing out of there. Now the new one didn't come with a gasket, so we'll just throw a little bit of fire caulk on there and then throw her back in there. See what happens. Get this old gasket off there first. I let you guys watch, but somebody broke my tripod, Train. So I can't do this with one hand, so I'm gonna have to put you guys down for a minute. As you can tell, the new motor is in place. Amp clamp is hooked up. Let's go power it on and see what happens. Alright, well, I know it's calling for heat because it's very, very cold downstairs. But those of you familiar with Train know that there's a 37-hour delay before anything happens. Oh, wait a minute. My bad. It's on right now. .27, that's really, really close to our 0.28 that we're supposed to be drawing. Now let's see if she fires up. Oh yes, we forgot to hook this up. Probably gonna have to cycle power now. Let's go back to the disconnect. Alright guys, 37 hours later, the unit is up and running. It did fire up. You can see back there. It did fire up. My amp draw on my high wire, right here, was initially 0.26, and it dropped out and just kicked onto our low fire, which is 0.13. Now it is making a little bit of noise coming from the bearing, which is kind of alarming. I'm chalking it up right now to it's very, very cold. And I'm just waiting to see if that motor warms up and our bearing noise goes away. But I don't really like that noise. It's not comforting. It doesn't make me feel good inside. We're gonna let it run for a little bit, guys. Gonna get some supply temps, and then we'll move it on. Yeah, we're done, guys. See you on the next one. What we're doing today is replacing an oil level sensor. And by the way, that's what brand new oil looks like. That's what slightly used oil looks like. So that's our brand new oil. And I'm going to be moving a little bit of that oil over here because I have to lower the oil level down below where the oil sensor sticks into the vat. And then what we have to do is I have to gut all of these electronics in order to get to the oil sensor because it's right about straight back behind this little tiny control board. First thing we're going to do is pull all the wires off our interface board, and then we are going to disconnect a few wires on our component box, and then a couple little bolts and whatnot, and that component box is supposed to just slide right out forward, and then we can get to our oil sensor. So let's get after it. Long sleeve shirt. There's our interface board. Make sure you don't lose this. So I got my perimeter bolts taken out, and I'm just sort of feeling out, trying to figure out how this component box comes loose. It feels loose, but I believe these little nuts way back here, I thought they just held the ignition key or the ignition box to the component box, but I think the component boxes are secured elsewhere. Alright, got the little 9mm nuts taken off, dropped my ignition control and this ATO board, I think it's called, down. I removed this Molex connector from the board in the back, this one as well. And I'm just gonna slowly try to wiggle this component box forward and see what happens. So I had to disconnect a couple Molex connectors, a couple of wires, taking pictures along the way so I remember where all of these go. Worst case scenario, guys, I have the same exact wiring and everything right over here, so normally I would recommend taking pictures, drawing diagrams, the whole 9 yards, but in this case I'm going to just pull this one down just to verify all my wiring. It's exactly the same as this one in case I forget something. So where is our oil sensor? Right here. This right there, that's the oil sensor we gotta change out. This is basically like the Aeon unit of fryers. Overly engineered, overly complicated for no reason. Anyways, enough complaining. Let's get this wiring pulled out. The wiring for our oil sensor, and then we'll get it changed out. This right here is our oil sensor. Now, a couple of these wires go down to our control box. I cut them just so I can remember where the ends go. The new one, here's our new one, has all the color-coded spade ends, so I know where they went. Just easier to cut them, and then I can just swap them out when I get the new one installed. You're probably wondering what's in this ball. I am also wondering that. In the manual, it simply says that there are extra electronic components in this. So of course, when I'm done, I'm going to take it apart and see what's inside there. So inside this oil sensor, there's a heating element and a thermistor, I believe, something that senses the temperature. And heating element inside this heats up, and if there's oil in the vat, that oil will dissipate the heat, and this will not be able to reach whatever set point that it needs to see at the control board. If there's no oil, this will be able to heat up and it will reach its internal set point, and that's how it knows that there's no oil. Seems overly complicated to me, but I'm not an engineer, so what do I know? Here's the fun part. Get to play in some oil. Try not to drop your phone. You won't like it if you do, I tell you what. was exciting. Right there on the right hand side, my right, that is our oil sensor. That is our temperature probe. Now we go down here and we can take our 7/8 crow's foot socket, get it on there, and start turning. Most of the time they'll fight you because they've been hot and covered in grease for so long, so I'm gonna have to get two hands on this. But once you break it free, you can just kind of use your hand most of the time. When I put these back in, I like to use a little bit of plumber's tape, just a, I don't know, a once around, just to keep any oil off of those threads while it's in there. And the problem with these oil sensors is that they were not able to recognize the oil anymore, and we would try to clean them, they would just get dirty. What I've noticed what happens with these is over the years, after you clean them with scratch pads, they build up oil really easy. They get dirty really fast. So after a while, you just got to replace them. Tip of the day, a little easier to hold your control box down, just throw some zip ties around it so it's not flopping all over the place. New sensors prepped. Again, just put a thin layer of plumber's tape along the threads here. That just, in my opinion, keeps any grease out of the threads. Not necessarily because I'm afraid grease is going to leak through it, only because I want that little tiny layer to prevent the threads from really sticking into the grease. Basically, if I come back and replace it, or whoever comes back and replaces this in the next couple of years, it'll help them out, make it a little bit easier. Alright, we got it started. I'm going to have to get two hands on this, as I have to grab that, spin the whole assembly as I spin that in by hand, and then we will start the super fun process of trying to rewire all this stuff. Flags go through the back. Weights. This. As I do empty terminals, because it's going to be much harder to try to fish a wire through once I get this back on it. I had to stop the recording there to get this component box in place because I wanted to swear really loud and I didn't want to offend you guys. So I got the component box back in place, got the control interface board all wired in. I went through, just double checked all my wiring, compared it to that side. Everything looks correct. I am going to put the oil back in, and I'm going to fire this side up and make sure that this works before I even begin doing the same process on the other ones. Now, again, this is my first time replacing one of these sensors, and it took me about an hour and a half. And a few things I'm going to do differently is, first thing I'm going to do on this next one is I'm going to pull the speaker out. That just makes it a little bit easier to reach some of the components. I'm also going to watch how I orientate. I'm also going to watch how I install this, because if you install it this way in the machine, you don't have enough room or don't have enough slack in your wiring to reach some of your control boards. So I had to flip it around inside, and that was kind of difficult. So watch how you position this. That'll save you 10 minutes. And then I may try to zip tie some of the wiring together just to keep it from flopping around, getting in my way, causing me a little bit of issue. Some of you keen-eyed viewers might notice this wire sitting here. I'm not sure what it's for. I believe it's for some sort of added option on these units, but they all have it. See? It's going to go through its little startup sequence. Now we don't have the filter pan in. We'll just hit confirm. This little light should kick on, and then our inducer will come on. And you can see right back there we have fire. And it does that. This is the melt cycle. So it'll do that on and off and on and off and on and off every 5 seconds. Keep watching. It'll fire back up here in a second. Maybe 3. So I'm going to watch it do this until I see a significant heat rise, or a significant temperature rise, rather. And so far I know our oil sensor is working, because obviously if it wasn't, then it wouldn't heat at all, because it's a safety device. Looks like we are all set. Circuit board. Let's see, this is really hard to do one-handed. Let's check out a wiring diagram. Let's see if a wiring diagram says anything about this. Sitting here in my office looking at this. Let's focus in right here, see if you guys can see that. This is our little egg-shaped device, which is this. So these red and yellow wires, that is to our thermocouple, and this little control board is our fixed set point temp control. Incoming power goes through here, of course. This black wire and white wire, these go out to the time delay relay board. That's these 2 wires right here. And then this yellow bundle, of course, that goes out to the actual oil sensor itself, to the heater. Somewhat simple. Looked rather confusing, and I didn't get a good enough explanation, so crack it open and see what's inside. Anyways, guys, hope you got something out of this video. Thanks for watching. Do appreciate it. Go ahead and hit that thumbs up button for me if you do like it. And, you know, share it with a friend who likes fryer stuff. Take it easy, guys. We'll talk to you on the next one. This is our project for today. Captive air makeup unit. The issue is it's apparently not heating. Can't really see inside there. This is a direct fire makeup air unit, meaning that there's no heat exchanger. We'll get that later. Alright guys, so here's the inner workings of this heated makeup air, or this tempered makeup air. As you can tell, I got no lights on my main control board. Here's my giant spark igniter, my giant transformer, my high limit,
some miscellaneous doohickeys, my actual blower motor contactor. This, I believe, is some sort of, I mean, it's a relay. I really don't know what it controls, though. Our modulating gas valve, pressure switches, intake air thermostat. So, now, I'm going to start with the obvious. I should have lights on this board. This is our main control board, does everything. Let's come down here to our schematic. This is our control board right here. Get you close up. So the first thing we want to do is figure out where power is coming in on this board, or where it should be coming in on this board. Let's see, so 6 and 7 looks like it'll have voltage coming in, possibly. 2 and 3 go to our neutral. 5 goes to a transformer. If we follow this right here, number 5 goes down to a feed one side of a 115 volt transformer, which controls our gas valve. Black, that's to our sparker, and that's to our electronic eye to sense the flame. So first, let's check out 6 and 7. I'm just putting this in there to give me a ground. Alright, so I have voltage on 6. I have nothing on 7. So let's go back down here. Let's see, PS01 high airflow switch, and then it feeds into this. So circuit number 6 could simply be sort of a logic circuit that lets the unit know that it does have actual airflow moving and it is okay to heat. Now, since circuit number 7, let's see, TS02 high temp and TS03 air intake thermostat. Since circuit number 7 has 2 thermostats attached to it, I'm going to go ahead and say that this is the circuit that I need to have power on in order to actually fire up and heat. So we don't have any power there. Let's go to TS-02, which is right there. High limit temperature switch. That guy right there. Now, obviously, first thing you do is push the button. No power there. Assume we have no power on the bottom one either. 0 voltages. Alright, so we don't have any voltage there. Let's back it up to TS-03. Intake air thermostat. Right there. Burner on-off intake air thermostat. Now, from what I can gather, let's double check this real quick. So, R and B should be closed if it's calling for heat. I should have power sitting at R anyway. So let's check R, which is going to be this top one. We have nothing. And we go over to this letter 9, or the letter 9, this number 9 right here. This is this terminal strip right here, this bank of wires. So I should have power at number 9. Which I don't. Let's double check down here. I don't have any voltage right there. And as you can tell, it's our gray wire, number 9, comes down here, goes into this conduit, goes downstairs to our control system. Now the other thing I was looking at here is this dotted wire right here. It's something they would have added in the field, but I just don't know where it would be. So it's number 10. Let's follow number 10 real quick. First, let's double check, see if we have voltage on number 10. Alright, we have no voltage on number 10. It is an orange wire that goes through there.
Okay, so that's the orange wire that goes through there. So number 10 actually connects up to right there. So that makes me wonder, this TS-02 high limit intake. Let's trace that wire out. Number 9, which is this gray wire right here, may be a control wire. Comes up, goes through here, across here, and it goes into the R terminal of our intake thermostat. Now, right now, R and B are closed because this thing's calling for heat. So B comes over here and it goes into number 10 right there. And from number 10, it goes into our high limit, comes out of the high limit over to 14, and from 14, then it goes into 7. Okay, I got it now. I know I have power on terminal number 6. I'm going to jump this very carefully to terminal number 9. We're going to see if this board actually lights up. And we have lights. Open control, operational control, airflow, PTFI, not sure what that is. I don't see any alarms at the moment. Let's go downstairs and check out that control block that they have and see what the issue is with that. As you can tell by that picture, we have a indicator light downstairs that says burner failure. Now, all I did at that control panel was move that rocker switch from manual to auto. So I'm going to leave it in auto, and as you can tell, we have an alarm right there. Should try to fire up, I believe, anyway. Nothing. We got nothing here. So right now, all my lights are lit up. I apparently have flame. Looks like we just lost voltage, possibly. Of course, the sun's shining. Let's block this a little bit. Yeah, our lights are off. Well, that's different. Alright, I don't have voltage coming from number 7. Right there. Well, I had to take a couple phone calls there, so I forgot what I was talking about. I know I could just go back and edit this part out, but I'm not going to do that. So, I think I'm off at my thermostat here, so let's just verify. I am. So 50 degrees, obviously the inside chamber is, over 50 degrees. But I remember now. What I was telling you about was this unit will not fire up because our pressure switch will not be satisfied with this panel off, which to me was confusing for a second. So let's take a look at this. All right, so panel's off. I'm going to come over here, I'm going to turn up my thermostat, click, that's on operational control, right? If we go like this, now if you remember from a little while back, our pressure switch circuit comes off of numbers, let's double check here because I don't want to say something stupid, number 6. So I have voltage for my low pressure switch circuit, or excuse me, my air pressure switch circuit, which, let's see, where does it go? Comes up over to this one. There's our voltage, and then it's supposed to go through here
and we just got a little bit of bleed through voltage. But this pressure switch isn't closed because I have that panel off, which some of you guys might know. You're probably saying, duh, obviously, but I didn't know that. So let's shove this back up here real fast, if we can. Panel's back on. Let's go back over here. We got lights and stuff. Let's double check this terminal right here. We should have 120 going through it, and we do. Fantabulous. Airflow. If everything goes good, I should have a flame in a second here. Any second now. And it's in some sort of alarm, so it didn't fire up. Which is really weird because it fired up last time. Our alarm light was because of a flame failure, of course. And also, I found out this PTFI, just our pilot valve. So what happens is when this thermostat is set to above whatever the air intake temperature is. So for example, I set it to 70 right now. Operational control light comes on. It verifies we have airflow. It'll kick this PTFI, this pilot valve will open up. We'll have 24 volts going to that. At the same time, our ginormous spark igniter here will receive 120 volts from number 4. Let's just double check that. Number 4 right here goes down to TR-03 ignition transformer spark plug. See, TR-03. So I'm going to verify power at the gas valve for my pilot, as well as power to my ginormous spark plug. There's my voltage to my pilot. It seems we have fired up again. Interesting. So we are intermittently not firing up. So I think what I'm going to do at this point, I'm going to order a new pilot assembly, a new spark plug, and we'll have to throw all that stuff on there. We are back at this captive air, makeup air unit. It's been about a week or so. We're going to be replacing our pilot assembly and our ignition transformer over on the other side. I got the air filters pulled out. We're going to clean those too. They weren't terrible, but I just want to ensure that we have the best possible airflow that we can have. So we're going to take those downstairs, clean them all out, bring them back up, reinstall them, and fire this unit back up. Should be a fun little time. I got the unit shut off right now. We'll start by pulling and replacing our ignition transformer. Then we'll do the pilot assembly, clean those off, put it all back together, and see what happens. There's our old pilot assembly. It sort of fell to pieces when I removed it. There's our new one. Alright, so for now, I'm just taking a 120 volt power source off of basically circuit number 6, which is just the logic circuit for my pressure controls, and I'm just jumping 110 volts, bypassing the control downstairs, going through my thermostats up here into my control board. It's really simple. I'm just robbing 120 volts from the logic side to the temperature control side. Let's flip this around, and we have fire. Awesome. All right, well, before it gets too hot downstairs, I'm going to shut this off and take those filters down, clean them out real quick, and throw them back in the rack. Don't forget, they do still have an arrow sticker on them. Pay attention to it. It's not really picking it up that well on camera, but these are nice and clean. Well, that does it for today, guys. Let's get out of here. Hey, what's up, YouTube? So today,
we are going to be installing an Hvac commercial air cleaning device right there. This unit is up to 12 tons. The other iWave, I can't remember exactly what model it is, but it's for 6 and under. This one's 6 to 12 tons. And I'm putting it on this 8.5 ton train unit right here. Now, if you're not really familiar with these Hvac devices, the technology isn't new. It's just been rebranded over the years. I'm not going to get into the sciences of it, why we need it, why people want it, if it actually does work, what it does to, you know, the virus. I don't want to say it, but the virus anyway. I'm not going to get into all that. I had a lengthy discussion about this on one of our HVAC overtime episodes, and I'll link that in the description or at the end of this video. So, with that being said, we open the box, we get some mounting stuff. Now, we're going to be mounting this unit right here on the side, right about in here. The directions say you can mount it in the ductwork. The preferred mounting location is after a pre-filter and before the cooling coil. An alternate mounting location is the supply air duct or the return air duct. Basically, you can install it anywhere in the airstream. Now, this particular customer wants them installed right here on these train units. Our evaporator coil's right here. It runs diagonally like this, right down to our drain right there. And they want it installed right here. Obviously, for installing one of these, do not put them on a panel, because that panel will eventually have to be removed for some sort of service. So that would be really stupid. Alright, so here is the actual device itself. Pretty simple. Comes with, I don't know, about 5-6 foot of cord here, all wrapped together in a nice little bundle. Makes for a pretty easy install. They're not terribly difficult to install. You're going to need a 4-inch hole saw and roughly a 3/4 inch hole saw right there. So first things first, let's go over here and lock out our disconnect. I like to just take my keys, put my keys in there because I'm not going to forget those, because I can't leave without them, obviously. So power's off. Next thing I'm going to do is I'm going to come around here. I'm going to take my panels off right here. I'm going to take all 3 of these panels off and kind of get an idea of how I want to wire this. These can be wired for 208, 120, or 24 volts. I find it's usually easier and faster to just wire it directly to the transformer. They do need to have power consistently. They always have to have power on them. And if you are installing one of these, the other thing you have to do is you have to set up your thermostat so the blower runs nonstop. So that being said, let's pull some panels off. Real quick here, right over there, way back in the corner, that's where it's going to be mounted. First thing I like to do is kind of mount it, get a rough idea where you want to put it. Keep in mind that you have to connect this, you have to have this wire going through this cabinet at some point. So, and also you want to watch out for these tabs, because these tabs need to be screwed down. Alright, not too shabby right there. Perfect. Now, if if you don't draw a smiley face, it's not going to work very well. And everything will just go to hell after that. So, let's put a hole in it. Right about there. So let's go ahead and mount this guy. Now I don't know if you noticed when I was showing you the underside of this, but there's a gasket that goes on the underside of this to keep the rain out, all the elements. So you don't really need to caulk anything around this. Alright, now I'm going to make a little hole right up down here. And then we're going to stretch these wires out a little bit. And we're going to jam them through. Like so. As you can tell, I got my wires pulled through. Now you may have to be a little creative when you're threading these wires behind that blower. I have a little hook that's on a long wooden stick that I use to pull filters out of machines. So that works perfectly. Just stick it in there, pull this through. Just be careful not to snag any other wires. So now what we need to do is we need to get this through here, over here, and into our transformer. So what I'm going to do on this is I'm going to find a spot right around the bottom here, take my 3/4 hole saw, make sure there's nothing on the other side, nothing I'm going to hit. We're good. Take our seal tight connection, put it back on. I find with these train units, you don't have to modify this wiring as much. It's a pretty good fit. If you're installing this on some other brands, you may run into some other issues, but I've installed them on Carrier, York, even a couple Aeons, and all you really need to do is run a little bit of extra wiring to them. It's really not that big of a deal. Once you get that connected, jam wires through the hole. Take your other little connection right there. Now, got to figure out what to do with our wiring. These two purple wires, I'm going to clip these off. These are just for an alarm system. If you have a building automation system, then you can wire these in, so if there's ever any issue with this ionizer, if it shuts off for any reason, it'll just set off an alarm. But we don't have that in this particular location, so we're not going to use it. So what I've done is I've ran 12 gauge wire to my wires that I poked through the cabinet here. Now I know I didn't need to use 12 gauge wire. I could use 18 gauge, whatever. I could also taken this 12 gauge wire and hooked it directly to the incoming power side of our contactor. There's multiple different ways you can power these. This is just how I want to do it. I'm going to take one of these double spade connectors. All right, got our panels back on. Let's get our keys out of here. Power it back up and see if we got a green light on this thing. We do have power. Now, besides this green light, there's really no other way to verify that this thing even works. We just gotta take its word for it, I guess. I know you guys probably noticed this. I'm gonna put some caulk around here. No big deal. All right, guys. Thanks for watching. Hope you got something out of it. If you have any questions or anything, feel free to email me or put a comment below, all right? We'll see you guys on the next one. What's up, YouTube? Here's our project for today. We have this train unit right here that's apparently not heating. I went downstairs, checked the thermostat, and it is calling for heat at the thermostat. I just got upstairs here. I'm going to check up here to see if we're actually getting a signal from that thermostat. Nothing coming out of here. Doesn't seem to be doing anything. So anyway, let's pull some panels off and get to work. Got my panel pulled off, and immediately we notice we have little blinky lights. Blinky, blinky. So then we go down here. There's nothing that really indicates what 2 flashes means. It's just got a bunch of mumbo jumbo about flashing, test mode, checking for DC voltage. Nothing that really helps me. Now, as I was standing here watching that light blink, trying to figure out what it is, I could hear my inducer come on, and then I smelled a lot of gas coming out of my my heat exchanger here. So, being somewhat familiar with these trains, I'm gonna see if I can get a power reading on that there igniter, because normally those are just bad. Simple. Those are just bad. So let's see if we can bypass this thermostat, initiate a call for heat again, and well, no, actually there's probably another call for heat already. We just need to cycle it, cycle power to it, and reset it so it's not in its lockout mode. So yeah, anyway, that's what we're gonna do. Got my igniter probe disconnected. Leads are ready to go. My meter is off right now, but we'll turn that on in a second. There's our igniter probe right there. Just comes right off of our ignition module. One side of our transformer, so we're looking for 120 volts. No big deal. I just gotta throw a jumper on there, initiate a call for heat, and see what happens. We got 113 volts going to our igniter, but we're not getting any ignition, so we have a failed igniter. So let me go see if I have one of those on my truck, and see if we can't get some heat for these guys. Just walking around, and I noticed this little guy is missing its top. Doesn't look like it's abandoned. Actually, I take that back. Judging by the lack of a Schrader core inside there, I'm assuming this is an abandoned unit then. Maybe I'll just have to take that home with me and do some experiments. Anyway, let's get back to work. It's time to focus. Alright, got a new igniter. There's the old one. Let's see if we can't get these 2 little 5/16 nuts out of there. If it'll focus right there. Good job, camera. Most of the time, those little 5/16 screws are sort of rusted in place. So it'll probably put up a little bit of a fight, but we'll see. crap, man, that is tight. Might try another way. Yeah, she had a rough life. New igniters in. Now I couldn't get these little 5/16 out. They felt really tight, and I didn't really want to break them off or run into a situation where they're just spinning around freely in there. So I opted for a different way. I just took this little metal L-shaped bracket that's right here. Take some needle nose pliers to gently pull it back while you pull the igniter out. Now here's the old one. Now these are a silicon carbide igniter. They're very fragile. Make sure you don't touch them with anything, including your fingers, because they will break in a matter of seconds. So anyway, let's fire this thing up and see if we got heat. Now I almost forgot to do this, guys. Look at the big picture while you're here. I should have done this before I went and got the part, but anyway. Check your belt. Our belt looks good. Pulleys look good. Nothing too crazy going on there. Everything looks pretty good in here. No red flags. Filters are good. Alright, let's put this cover back on and we'll power it up. Alright, inducer's on. I don't see anything glowing. There we go. And we have fire. And fire is good. Right down here it says temperature rise of 25 to 55 degrees, or whatever language that is, 25 to 55 degrees. Now our return temperature is about 64. Right now we're climbing, we're about 88. 90, so we're getting there. Just a quick update before I go. We're at just about 100 degrees. So we're well above our 25 minimum temperature rise. So we're about 35 degree temperature rise. So that's going to do it for me tonight, guys. Hope you enjoyed this little video of changing out a Trane igniter. American Standard, whatever you want to call this thing. It's a Trane either way. Alright guys, we'll see you on the next one. Hey, what's up YouTube people? So, today we got our first no heat call of the year. For me anyway. Maybe not for you, but for me. So a little Lennox unit here.
One of my guys found that it wasn't heating on a preventative maintenance call, so we're gonna open it up and see what's wrong. As you can tell, I took the door off, put it over here. It's really windy out, and what happens with these is they just bounce around. The way this hinge is laid out, it just bounces around and gets beat up and bent, and as you can tell, this one's been beat up and bent for a long, long time. So before I do anything, take the door off, we'll set it over there, and we'll come back over here and put this thing in test mode. One of the things I immediately notice is terminals on that contactor look like they've been a little warm at some point in time. Alright, so I'm going to hit this shift dip switch. Unit test. C1 comes up on the little screen up there. Then we're going to hit this once, twice, H1. I'm going to go H10, then I hold it down until I see a little tiny decimal point right there. And then our heat should be engaged. Oh, yeah. Inducer's running. No sparking. There we go, we got a spark. And we have full ignition, which is odd. Let's take this out of test mode. Put this back here, shift back over here. And we should be in normal operation right now. Now, I'm going to turn it off and just sort of visually inspect everything. I can figure out how to work these doors. So I'm kind of curious to know why I'm here on a no heat call that was found on a PM. Belt's nice and good. Slightly out of alignment, but not terrible. Not terrible. I know it's probably hard to see at the proper angle, but we're maybe a quarter inch this way. Not terrible, but nothing obvious over here. We'll check the heat exchanger on the other side in a second. Looks like the ignition module's been replaced at some point. Let's open up this cover here. Let's see if the contact points in that contactor are heavily pitted. That is a compressor contactor, so it shouldn't really affect anything to do with the heat. So again, that goes back to, why am I here? Am I here because there was actually an issue, possibly an intermittent no heating issue? Or am I here because the previous technician who did the preventative maintenance maybe didn't know how to initiate the test cycle? Who knows? But we're going to check everything out as much as we possibly can. Contact points look good. I almost wonder, so those contact points look really, really good. I'll bet you this contactor was just replaced. sometime anyway, probably over the summertime. The wires are nice and tight. So that's not it. Well, let's go around and check our heat exchanger. How about that? And then we'll fire it up one more time just to see if maybe we can catch it intermittently firing. All right, heat exchanger. It's not terrible. It's also not the healthiest looking heat exchanger I've seen. I did go through all these rust spots with my screwdriver, scraped them all. It's just surface rust right now. Probably next season we'll probably have one of these little seams on the side or something like that will start to open up. But she's good. She's good today. She's good this year anyway. Alright guys, so I'm just going through kind of checking some of the wiring connections. And this little pressure switch connection right here, it's pretty corroded. Not real excited about that. It's not terrible. I mean, it's still going to make some sort of connection in there, but I just don't like it. Let me come down here. This, if I can get in there and show you. Right there. Our sparker wire is somewhat melted. Now that could probably cause intermittent issues. It may or may not spark every single time. Also, looks like somebody forgot to put some screws back. That's not cool. Hey, look at that. So I just touched it and it came off. So yeah, it's bad. So we're gonna get a new sparker wire, a new sparker, flame rod, and I'm also gonna quote that pressure switch just because I don't like the connections. So that's what we're gonna do. What do you guys think? Think it's a good idea? I have sort of what you might call like an always list, right? And I'm sure it varies from company to company and technician to technician. But for example, if I'm going to replace this wire here, normally, if everything on this unit was the same age, I would replace just about everything. I would do my spark wire, my spark igniter, my flame sensor, my pressure switch, my rollout switch, and I would do an ignition module. But the ignition module is fairly new, so I'm just going to do the rest of it. But the way I look at it is, there's no point in replacing just this wire, obviously, and leaving the 10-year-old spark igniter in there. And there's no point in doing the wire and the spark igniter and not doing the flame sensor, which is rusted out as well. Not terrible, but it is rusty. So there's no point in doing half of the components that make this thing heat. There's just no point. In the middle of winter, I don't want to come back and replace this flame sensor after I've replaced the spark igniter months ago, or replace a pressure switch after I replaced an igniter and a flame sensor. Makes no sense. So this is where I've kind of started to develop these always things, and I'm sure you guys do it. For example, you know, if you do a compressor, you always do the contactor, and depending on the layout of the machine, I almost always do condensing motors too. I don't install brand new compressors with old, aging, slow-moving condensing motors. It makes no sense. For an extra $200-300, if I can ensure that the brand new compressor is going to last longer with a brand new condensing motor, I'll do it. Since I'm on a ranting path, another thing I'm going to point out to you guys, turn these knobs the right way when you're done. That one's not quite right there. There we go. Make them nice and pretty, alright? Drives me crazy. See, look at this. That one, this one. It's not that much harder to do. Turn them all the way. There's a little groove in there that's going to keep it from, you know, slowly vibrating. This is the open position. Turn it this way, yeah, it's kind of closed. Probably won't come open, but you never know. Turn it this way. you'll feel a nice, gentle little click. All right, that's all for today, guys. I'm gonna quote some parts out. As soon as I get approval, I'll bring it back. We'll install these little parts, and we'll see what happens. All right, take it easy, guys. And we are back. As you can tell, got all new parts. My igniter, flame sensor, pressure switch, new rollout switch, and an ignition cable. So, let's get started. Out with the old, in with the new. Catch our wire. Good. Now let's do our pressure switch. Now you'll notice this pressure switch is a little bit different. It should function exactly the same. Alright guys, just having a little bit of trouble with this igniter, this spark electrode. Couldn't easily just fish it out of there like I was hoping without breaking it. So what I'm going to do real quick is right along here, you see all these four little bolts that hold this, I don't know, burner assembly in place, or these burners in place. I'm going to take those up, and then hopefully this burner just kind of pops right out, and then I can just slide this igniter out real quick and fast like. Alright guys, there's some footage of a screw coming out. Alright, slide that out of the way. Yeah, much easier. Here's our new one. Spark, and we got fire. If you guys can see that at all, temperature, it's up over 100, so we are good to go. Alright guys, simple little repair there. Hope you got something out of it. I did. Fun hanging out with you guys. We'll see you on the next one, alright? Hey, what's up guys? So, I just wanted to give you a quick little tour of my day. I think I stumbled upon a super tech breeding ground here. I apologize for the wind. I don't know if you guys can hear me very well or not. Let's get over on this other side here. Apparently somebody changed out this ice machine at some point in time. They left that one over there, just chilling. And they left about 397 foot of line set, just flopping around.
which, as you know, isn't going to create any sort of oil trap or nothing. I'm actually here to work on that stuff right there. We'll get to that in a minute, though. Here's another sign that you've stumbled upon a super tech breeding ground. Look at this. Fossils. So, let's walk around over here. Dun, dun, dun. This is one of their ice machines right here. I don't care about that though. So this is what we got going on. This unit right here is hooked up to a sandwich station, a little reach-in cooler that's warm. Now this is basically how I found it. I've had about 5 minutes to kind of play around with it. When I got here, it was off, which led me to my first clue that it was off, so it had no power. So turned it on, and let's see if I can squeeze my ass over here. Hopefully you can see that. The sun's really bright for some reason today. Let's turn it on. Amp draw climbs up to about 4, which is about right, I guess. Near about right. There is liquid in that sight glass, but it's not moving. You'll also notice my condensing fan motor isn't coming on because somebody has put a little fan cycling switch on this unit, because this unit is not designed to be outdoors. It's not an outdoor condensing unit, so there's no headmaster on it. So they put that on there to kind of bypass it. Or not necessarily bypass it, but you know, to try to maintain some sort of pressure. But anyway, what I'm going to do, since our compressor is running right now, I'm 99% sure that thing's just not pumping. So looks like I only have, I don't have any other place to hook to. So I'm only able to hook to my suction side, but I have a feeling that I'm going to get no pumping action on this bad boy. So let's hook up real fast and see what's going on. All right, gauges are hooked up. Fired up. Got about almost 5 amps right there. Suction side doesn't look too healthy. Looks like our compressor's pulling it into a vacuum. And our pressure switch isn't telling it to shut off for some reason. Well, now let's turn that off. As you can tell, it's starting to equalize. See, our pressure switch should be turning that off for us. Let's see, we're not bypassed right there. Interesting. All right, well, let's dig into this thing further. Yeah, before I forget, guys, I wanted to show you this. That little number right there. It's not super terrible, but I mean, at least they tried to do the right thing by adding a headmaster to the system. You know, they just got an elbow here, they just bent this sumbitch right around there, you know, and I don't know. Could have made it look a little bit nicer, but hey, who am I to judge? I'm not a super tech. Anyway, I'm going to mind my business and get back to what I'm looking at here. So, what do we got going on here? There's my low side pressure, just a hair above 0. My cut-in pressure is roughly 40, right? And my differential is maybe 5, so cuts out at 5, cuts in at 40. Obviously, right now, it shouldn't be trying to cut in. But that beeping noise tells me otherwise. It is trying to cut in. Even though we have 0 pressure in there. And right over here, we got one of these fancy stickers. So we have a system that's really not supposed to be outdoors. I mean,
Obviously, you can put it outdoors with some modifications, as they have done. Pressure switch is bad. I don't know where the leak is, so we're going to have to talk to the customer and see if they want to proceed with a leak check. This is one of those customers where we get a very, very low NTE, not to exceed amount. So basically, I get about an hour to diagnose it. Yeah, I know it's stupid, but it is what it is. So let me go talk to the customer, see what they want to do. All right, guys. Hey, what's up, guys? I'm ducking down behind this train unit here to try to avoid the wind, because apparently I am in the windiest place in the world right now. Anyway, talk to my customer. They would prefer me to just change out this system, new condensing unit, new evaporator, and a new line set, and get them up and run them permanently. Apparently this unit has been giving them nothing but trouble, so that's what we're going to do, all right? So stick around. If there is a part 2, I'll post it up later. Just wanted to give you guys a quick little tour of what I'm doing today. See you guys in the next one. Hey, what's up, guys? So today we got a walk-in cooler that's at 48 degrees. According to the location's management, it's been at 48 degrees basically all day. So we're gonna get in there and see what's going on. It's been a minute since I've gotten to work on a walk-in cooler, so this will be fun. I've already mentally prepared by binge watching all of Chris Stefanovich from HVACR, watching all of his videos before getting to this service call. So I should be ready. It's time for a big picture diagnosis. All right, so follow me, guys. Let's go see what's going on here. All right, guys, we are at temperature right now. That's only because they had the walk-in freezer door open for a little while here. So there's our low profile coil. As you can tell by the arrows, air goes in, comes out the sides, right over there, right over there. So the first thing I'm going to do is take a quick peek at the inside, make sure the evaporator's clean, and then I will probably go over there to the thermostat right there and see if we're calling for cooling, which we probably are not right now because we're at temperature because the freezer door was open. So I'll just hang on to that sensing bulb for a little bit and warm it up, and then see if that thermostat is actually functioning. Then we will go from there, but we're not froze up or anything, so that's a good sign. A little bit of frost on the coil. Not terrible though. So, not sure if it's actually picking it up on camera, but looking through this fan blade, the evaporator is clear. It is clean. A little bit of dirt, but nothing that should keep it from not working. Our finger guards are pretty dirty though, so we might pull those off and clean those real quick today. But first, we'll get to the major issues, and then we'll get to the cosmetic issues. Alright, going directly to our solenoid here. We're wired up for 240. Testing my blue and my black. It's basically showing 0 volts, so I should be reading 208, and I'm not. So let's go back to our thermostat. That is now our suspect. So we have 0 volts going across there. Our thermostat is closed. I just turned it down. I'm 99% sure when I was checking it earlier, it was open because it was satisfied, because again the freezer door was left open. So the potential difference that I read before was just the thermostat being open. I don't know if you guys can hear that, but our
solenoid is open, and I hear what seems to be an underfed TXV. There's a little bit of a hissing noise. So I think it's just about time to jump up on the roof. Alright guys, we are up on this freezing cold roof in front of what I'm 97% sure is our cooler coil, or our cooler condensing coil, condensing unit, whatever you want to call it. Real quick, basing that decision on, I'm pretty sure it's not our freezer because we don't have an X terminal, you know? And usually our X terminal is our defrost termination switch, and then also our number 4, or is it number 3? Yeah, number 3 would be our heaters, and we don't have a number 3. So, and then also you can just tell by the line set. If you ever have any, I guess, issue locating a unit, and it's not labeled, and you can't determine what it is based on the defrost setup, you know, just look at the line set compared to the building. This one's pretty easy. Right underneath me is my cooler, and then right over here towards the back of the building is my freezer, so it's pretty easy. But that's not always the case. It's not always going to be straight down like it is here. But anyway, back to the subject at hand. We are in defrost. Now, I am going to guess we're just stuck in defrost, and that's what's going on here, but I'm not 100% sure. So we are just going to make a mental note of where that arrow is right now, right there, and we're gonna sort of walk away and come back in about 10 minutes just to see if it's advanced on its own. I don't want to move it, and let's say it's one little bad spot in the gear or this motor in the back of that, and if I turn it and see if it's physically stuck, then I'll break it free, and it might start working, and then I'll, you know, call it good and move on. And then we'll be back in, I don't know, 24 hours or whenever it gets stuck again. So I'm going to leave it the way it is, come back in 10 minutes, and see if it's advanced. Each one of those little tabs is only 15 minutes, so it should come out of defrost in about 10-15 minutes here. Well guys, our defrost clock did come out of defrost on its own. It's in refrigeration mode right now, so that's apparently not our problem. My main issue right now, see, I don't know if you guys can see that right here. Look real close. We got a lot of bubbling in our sight glass. So let's pull this cover off and further investigate this little deal. Obviously, I've gauged up to the system. I ran my electronic leak detector all around the condenser. I'm getting a hit right here at the bottom of the king valve, as well as the port on the other side of the king valve. So I'm just going to verify that I have some sort of leak with bubbles, because it is really cold out here, and who knows, my leak detector could be messing up. Anyway guys, I took the cap off my king valve, I tightened up that packing gland, and there's no more bubbles coming out of the port on the side there. And you'll see a lot of bubbles on there. That's just because there was some air trapped in there as I was screwing the cap back on. But we are free and clear. Confirmed with bubbles when I was done, of course. Now we're going to power it on and add some gas. You'll notice I don't have a scale. I weighed the tank downstairs. I'm just going to fill it up because it's about 10 degrees outside right now. So I'm going to clear my sight glass. And in doing so, clearing my sight glass at a 10-degree ambient temperature, I'm pretty well confident that I have my winter charge. So we shouldn't have to worry about it. The only thing I am worried about is not having enough pressure in this tank to get anything done.
Could have probably taken the tank and put it in a sink full of hot water for a little bit, but did not do that. I think I'll be able to suck it in. Let's see. Sight glass is almost cleared already. Alright guys, let me wrap this up and I'll bring it back around here in just a few minutes. We're all charged up, sight glass is clear. High side pressure is a little bit low. I'm going to double check my headmaster back there. Using my hands, it doesn't feel like it's not in bypass mode anyway. It is bypassing the condenser. So I got my discharge back here coming in, and then going right in through the headmaster body into my receivers. Feels about the same temperature. And then the line down at the bottom, which is the liquid line off the bottom of the condenser, feels nice and cold. Let's see. It's an LAC 148. So I believe that's going to maintain 148 psi. All right, so we got 20 degrees of compressor superheat, 21 degrees subcooling right there. Oh, and something kind of funky that I don't know if you guys have noticed, but I haven't seen too many of these out in the wild yet. So here's my liquid line coming out of my receiver, goes down into my sight glass. That's kind of hard to see back here, but then it goes back and the loops back into the bottom of the condenser, where it looks like it makes one final loop around. Then it comes out here, goes through my filter dryer, and then goes downstairs. So looks like they're just, I guess, subcooling the liquid after it comes out of the receiver, I guess. So anyway, that's cool. Literally subcooled. Real quick, guys, this headmaster valve here, the LAC 4-148, I did find a Sporlan document just to confirm that the nomenclature 148 does mean 148 psi. So I'll put a quick little screen cap of that here in the video. Yeah, we are apparently maintaining just about 148 psi, which seems kind of low to me, but I guess I'm not an engineer, so apparently that TXV can handle it. The evaporator temperature is a little bit cold, but I had to set my thermostat downstairs down to 20, so we could be running really, really cold right now. So I'm gonna get down there and crank that back up to 35 before it freezes up. All right, we just cycled off at about 32.5 degrees. You can tell I mounted the sensing bulb in a much better location. It was just under that strap, and obviously with that strap it's going to read wall temperature, possibly even the metal strap temperature. And also I mounted it horizontally just because I sort of view them as sensing bulbs for TXV, where they may have a small liquid charge in there, and if you mount them vertically, that liquid will run down into the cap tube and you may get some fluctuations, is the technical way to put it, I guess. But yeah, we're at 33 degrees. Now you might be wondering why I run them so low. I'm running it this low per the facility manager. He wants me to run it at 32, off at 32 exactly, and he wants to come back on about 35 to 38 degrees because they do store deli meats in here. So that's what he wants. This system does have a defrost clock, as you saw, so we don't really run the risk of it freezing up. So anyway, guys, that's all for today. Hope you enjoyed it. We'll see you on the next one. I don't know if anybody out there can hear me. The year is 2052, and the Earth is ravaged by cold because everybody just releases R22 in the atmosphere. and our atmosphere is now gone. I believe I'm the only man alive, and I am out walking the frozen tundra looking for any signs of life. If you can hear me, please send out a signal, because it is freezing out here and I need shelter. No, anyway, that's all a lie. We're actually here to look at some of this stuff. We got a bread oven that's not working, and the reason it's not working is because it cannot satisfy the pressure switch. And it cannot satisfy the pressure switch because one of the exhausts is bad. I am here on the coldest day of the century, just trying to figure out why. So, stick around, guys. See if we can find something cool today. One of the problems I'm having is I don't know exactly which exhaust hood it is. It's either this one or this one. Like my mittens. Yeah, these are cool mittens. You can fold the tops over and release your fingers. So let's check out this piece of crap here. Well, yeah, it looks like that one hasn't worked in a long time. That one's not our issue. This one must be our guy. Yeah, look at that broken belt. Motor doesn't feel too great. Alright, well, let's dig into this. Alright guys, I apologize for not getting any footage of this, but it was very difficult to obviously try to set a camera up anywhere around here and do any sort of work, but do a quick little recap here. So I was able to verify power going through my switch. I have the motor removed, obviously. So I had power going to the motor, but it wouldn't actually do anything. If you look over here, looks like somebody let the smoke out. Yeah, it doesn't even want to turn. So she's locked right up. So we need to find us a new motor. Well guys, I'm off the roof. I'm inside this nice heated mechanical room. And bam. Now I just recently started carrying a little tiny folding table in my truck because I've ran into a few issues where I needed a work surface. So I threw this in my truck and got the old motor pulled off. New motor's right there. So I'm gonna swap the pulleys out, wire a new SJO cord on there, and then take it back upstairs and bolt it in place. It's gonna be much easier doing it down here than up in the snow. So yeah, tip of the day. If you don't already carry a little table, if you got the room for it, throw a little table in your truck. You might need it someday. It'll make life a little bit easier for you. Alright, first thing we gotta do is get this pulley off without breaking it. Alright guys, not sure how well this came across on camera, so I think I had a bad angle a little bit ago. Anyway, so my pulley puller only goes into the pulley, I don't know, just up to the end of the tip there. So I had to get a little bit creative, and what I'm going to do is a little bit of redneck engineering. I'm just going to take one of my 5/16 chucks, put it in there, and use that to get this pulley off. Yeah.
Alright guys, new motor. It's mounted on its plate. It's all wired up for, I believe, the correct rotation anyway. It doesn't specify which rotation it's set up from the factory, as far as I can tell. I'm sure it's probably in this nomenclature here, but I don't know. It just says to reverse it, interchange these two wires. So I'm assuming it comes wired up for clockwise rotation, which is what I need. So wiring was pretty simple, nothing crazy. I didn't get any of that on video because my hands were in the way the entire time. But I don't know if you guys are in that sort of thing where you want to see my hands. If you want me to become a hand model for you, just leave me some comments below. All right, for all you weird cats out there. So now we just got to get up there. Yeah, I left a rope around here. Yeah. All right, let's go. Well, it's super bright out here, so I don't know how much of this you can actually see. I got my motor kind of mounted. It's loose right now, so I can move it back and forth once I get the belt on there. Since there's no belt tensioner, I just tension the belt by moving the motor this way or that way. So, as you can tell, my pulley sits a little high. Now I can tap it down a little bit more on the motor shaft, but I don't really want to do that. So I need to try to raise this old pulley up a little bit, which is going to be interesting because it's been here quite some time. So go grab my pulley puller, some WD-40. We'll lube this thing up and see if we can't get her to move just a teensy tiny bit for us. All right, motor's completely mounted. I got some pretty good tension on the belt. Pulleys are properly adjusted. Bolts are tightened down. I put a little bit of grease in these pillow bearings. I think that's what they're called anyway. Got my SOJ cord nice and secure over here. Spare belt, yada yada yada. Feels like we got proper rotation. All right, now all we got to do is go downstairs and make sure our bread oven can fire up. All right, guys, so as you saw a little bit ago here, the motor, when I had it up and running, was pulling about 13 amps, which is just about double what the motor rating is, or the plate is, I guess. You can see it way up there. It's rated for 7 amps. So I let it run for a little while, thinking that maybe it just needed to warm up, or maybe our bearings were a little stiff, so I put a little bit of grease in them. But that didn't really seem to make much of a difference. It got nice and warm and went off on its thermal. So I'm going to pull the motor off real quick and just double check the wiring and see if maybe something is miswired, which it's not a dual voltage motor, so I don't understand how something could be miswired. It's a 115 volt motor, and I measured 121 volts coming in. I also went downstairs and measured 121 volts that feeds this line. So I'm a little bit confused now. Some days I wonder why things that should be somewhat simple are not so simple. So here's my wiring real quick. Let's take a look over here. Now to reverse rotation, just switch around the red and the black leads. So right now it's set up for clockwise rotation. Red on the number 2, black on the number 5, line 1 and 4. Now if you look close. I don't know how well it's going to show up, but red right there is on number 2. And black is definitely on number 5. I have my incoming voltage on number 1 and number 4. So, what would cause this motor to draw such high amps? Very confused. Alright, I'm going to leave this motor out and turn it on and see if I can see what my amp draw does then. So my motor's just kind of hanging out in here, positioned so that it hopefully won't fall. It's still really warm to the touch though. Let's turn it on real quick, just see what kind of amp draw we got initially. Alright, well, with no load on it, we're pulling 6.5 amps, which is right where it should be. Here's a life lesson for you guys. When you're changing out a motor, check your horsepower. I went down and checked the data tag on the other motor. The other motor is a 1/2 horse. So this motor is basically just too small. And I was careless because customer supplied me a motor and I made an assumption that it was the correct motor. Don't make assumptions, guys. Double check everything. Just pay attention, man. It's the little details that'll come back and ruin your effing day. Just like this little detail has ruined my day. Because not only do I have to waste time removing this new motor, but I'm going to be here another half a day putting it back on, putting another motor back on, and basically repeating the steps that I just did. So, all right, let me go get a new motor. We'll swap this out again and see if we can't get it right this time. We got our new motor in, our second new motor, and you'll notice it is actually 1/2 horse, 1725 RPMs. It should be pulling right around 8 amps. I adjusted my belt and I adjusted the pulley so that the belt's not riding on the outside edge as much. Basically, I'm reducing the size of the pulley. Let's see what kind of amp draw we're pulling now. That's right where we want it. Let me get all this wiring tidied up and I'll go downstairs and make sure that big old oven's working. Looks good. Well, that's no good. We got to see what's going on with this freezer. Well, so we got a little bit of a defrost issue, but what I have noticed though is a lot of these low profile coils, apparently in this application, they do have a little bit of droplets forming, only because these low profile coils don't come with fan delays. That's usually a separate item. It looks like we got a little bit of frost on the coil. So that's good. Looks to be relatively even. Got a nice steady stream of water coming off of that. Oh yeah, the floor is nice and wet. Let's see. Yeah, that seems relatively even. I know you guys can't really see this, but up inside here, looking at the inside of the evaporator, it looks relatively clean. I'm going to get a better look here in a little bit, but just for those that don't know, air goes up into the evaporator, through the fans, and then out this side. So, alright guys, let me get some tools and a ladder and see what the deal is. Alright, we are up above the walk-in cooler and the walk-in freezer. Over here, they keep their tankless water systems. Don't know if you guys can see that, but let's see if I get a good picture of that. There we go. Got a nice steady stream of water pouring out of that tankless system. So my initial thought is all this water dripping down the plastic bolts into the evaporator froze up, and obviously it would cause airflow to be a problem, so it wouldn't cool anymore. But we're going to give her the old big picture here. So get some pictures of this, send it off to the facility manager, and we'll get up on the roof and double check our condenser. Man, there's a ton of water that was just trapped inside there. You'll notice right back here behind this pump, we're just shooting water out of there. So this is about where it goes from a refrigeration problem to a plumbing problem. So I'm gonna get the facility guy on the phone and see if he wants me to shut down his hot water. They have a secondary system right there, so it's really not that big of a deal. We'll just shut this one down so it's not leaking anymore, and then I will continue on to big picture this girl. I mean the condensing unit upstairs, just to verify we're good. Alright guys, so we got the water shut off, no longer spraying. See, shut off right down there. Again, they have a secondary system, so they'll be fine till they can get a plumber in here and fix or replace this. And in the meantime, I'm gonna actually get a mop up here, see if I can get some of this water to stop going down these bolts that are holding our evaporator in, because what it's doing is it's just tracking down these little bolts here, dripping right into our evaporator coil, right along the sides of it, and of course freezing up. Now, I'm 90% sure that's our only issue, but of course we are going to verify a couple other things, get up on the roof, just give it a visual check, and then watch our temperature drop. Apparently moments before I got here, the staff had cleared all the ice off of the evaporator coil. So it was about 30 degrees before I got here apparently. It's down to 22 right now, so we're going to continue to watch it. This right here is the aftermath of the manager cleaning the ice off the evaporator coil. Luckily they didn't use a screwdriver, so the evaporator coil still works. No holes in it, no nothing. Huh. That's a fun noise.
Let's see. I think that guy needs to come out here and do something. Alright guys, so it took me a little bit to get to this point because I was hounded with phone calls from A-Team Adam from the HVAC Overtime Show. He just wanted to quiz me on boilers. He had a question about boilers, and he knew that I knew a ton about boilers, so he called me and I got him through it. Anyway, we're all gauged up. The only reason I'm gauging up to this system is just to verify everything. And it looks like we literally just pumped down and shut off. Well, snap. Anyways, I was going to show you that my low side and my high side suction pressure were right about where it needed to be. My superheat's probably going off the charts now. Subcooling's 10. Superheat's about 25. It was about 25, I mean. It's up to about 30 right now. But again, that's compressor superheat. Keep that in mind. And my suction line goes down into a heated space up above. Well, it's kind of a complicated situation, but this restaurant shares ceiling space with a restaurant next to it, and the suction line has somewhat of a long run anyway, and also the top of the freezer is flooded with water. But yeah, we are looking good. So I'm gonna go downstairs, just verify that box temp, and then I'm gonna get off this snowy roof. Let me bring it back real quick. I forgot a couple things. So real quick, I don't know if you noticed, but my suction line dryer, it's garbage. I have addressed that with the facility before. They don't really want to do anything with it now. I assume when something major breaks, then they'll finally allow me just to straight pipe it and get that out of there. Also, I double checked my headmaster. We are properly bypassing our condensing coil. Sight glass, nice and full. The other thing that I'm going to do is I'm going to crank this over into, oh, by the way, I've also been watching this. Even though I don't suspect that this was an issue, I have been watching it. So before I get off the roof, I'm going to crank this over into defrost real quick. That is kind of sticking right there. Alright, well, we got decent amperage going through our heaters, but even though this thing appeared to be moving, and I didn't time it, I didn't set up a stopwatch, but this is rather tight. Yeah, I don't like that at all. See? This could have been a callback, but yeah, we're definitely changing that thing. So, let's shut her down and swap her out. I'm sure you super sleuths noticed in this pink package down at the bottom here, there wasn't a secondary defrost clock. Now, normally I don't install just random parts that I find stuffed inside of units, but I just got off the phone with the facility technician who normally takes care of this location, and he did indeed leave a spare one up here because he said he frequently changes those. So yeah, he left a spare one in here. So I'm going to use his defrost clock, slap that guy in there real quick, and move it along. Got a defrost clock. I'm pretty sure there's a police chase in the background. Maybe I should go over there and throw my screwdriver down the road, see if I can hit the driver. Local curious HVAC guy stopped a police chase with his Lennox 9-in-1 screwdriver. I'm not gonna have that, right? What do I know? Flop this guy right there. Well guys, we are at temperature. Still a little bit of ice on the floor. A little bit up there as well. So anyway, the little droplets of water up there. Again, these units don't have a proper fan delay, so that's why this unit is set up for 4 45-minute defrosts, and it just ends defrost on termination. But I told the manager, since this box is already empty, they should just shut it down, let it thaw, get all that water off the floor, any water that's in the seams, up on the ceiling, because there's still a little bit of water that's going to drip down. So, but that's all I can do for today. Hope you guys got something out of it. I'll see you on the next one, all right? All right, guys. Just got called out to an emergency. No heat in the kitchen of one of my regular customers. It's a restaurant. So I'm thinking either they really don't have any heat, or the makeup air has failed, since it's like 10 degrees outside. So we're gonna go inside, say hi, check it out, and then probably get up on the roof. So I'll bring you along for the ride. Kitchen says it's 70. Dining room is 71. Well, no idea what they're talking about. Alright guys, so we're up on the roof right now, and I know I showed you satisfied thermostats downstairs. So what I think is happening, this unit right here is the only unit running so far. I got a temperature probe in it right now. I'm going to get a temperature rise of it. This tempered makeup air here, as far as I can tell, isn't running. These filters are trashed, man. So I bet you this unit's locked out on some sort of failure to ignite or something code. And this other unit, which services the back of the house here, inducer's running, no hot air coming out of there, so it's off on some sort of safety. So the complaint was the restaurant would feel really, really cold in the morning. This location goes into night setback at about 10 o'clock. It looks like we're off on a satisfied thermostat. All right, we got up to 112. All right. So anyway, this location goes into night setback down to 65 degrees at 10 o'clock at night. And the whole store cools down a little bit. And then at 5 o'clock in the morning, it goes back into its normal temperature of 70 degrees. And it takes it about half a day to get up to temperature. And that is because this is the only unit heating up the location, right? So what I'm going to do is pull this cover off and make sure that we did shut off on a satisfied thermostat, because I don't want to overlook anything and have to come back out here. Real quick, I know you guys probably noticed this. That's not my mess. If you guys ever install one of these iWaves, don't do that. It's real simple. You see this little retainer right here? You can take that apart. You take that really apart, you can take this whole mess of crap and you can slide it through there, and you just take the steel tight connection and put it, I don't know, like over here. And then this way you only have that much wire, you know, that much whip, and you take this and run it to wherever else you got to go. Also, you notice that power went out when the blower shut off. So whoever wired this up must have wired that directly to our blower, or to the blower contactor, or somehow it's connected to the blower. These are supposed to be wired so they're hot all the time, and your blower is supposed to be continuously running. So, but first and foremost, we have to deal with this heat situation. So let me grab my meter from over there, bring it over here, and like I said, verify that this is off on a satisfied thermostat real quick. Heat exchanger is good. Thermostat was off, was not calling. It has since turned back on and is calling for heat again. Belt looks good. So let's go ahead over here I'm gonna check this makeup air first. See if we can, actually I don't even know if this one's even firing up. I can't see into this little burner observation port. Can't see nothing in there. Junk. Pretty sure it's not fired up though. Alright, well, I'm gonna have to fight that off there, it looks like. Our makeup air appears to be fully operational. Now, since I can't really look into this observation port, I went around to the other side and I popped the panel off real quick and just verified that we do have a little bit of flame. Of course, since I popped the panel off, it shut off on pressure. One of the air proving switches really fast, but I know it's operating, so we need to direct our attention to this guy finally. Before I get too far into it, I popped the panel, checking my heat exchanger. It's not terrible. Maybe another season or two out of it. Don't you touch that. You don't touch that until you look over here and you figure out what our fancy little code is, which I can't see in there. Where the hell is it? Oh, there it is. I don't think it's coming through on camera. So 2 flashes. Limit switch fault. So our limit switch. Alright, so now we have some direction to go into. Let's shut this off. And no schematic back there, of course. Schematic's back here. We'll pull this, check out our schematic, pull this, and figure out which limit they're talking about. Let's see if I can do this one-handed here. Ringing through. So our limit switch apparently has reset. It's also rather loose. Let's tighten that down real fast. Now we need to figure out why it went out in the first place. Then we'll reset the unit and see if it fires up. Yeah, our belt's good. Blower's nice and clean. I mean, pulley does have a beveled edge on it. I think I might adjust that pulley. Yeah, 'cause it's sitting in there. It's riding in there pretty deep. So, yeah, we're gonna adjust that pulley and bring that out a little bit. Get a little bit better airflow. But before I do that, I'm gonna fire it up just to make sure that it does fire up. Let's check filters real quick. Jeez, bro. I mean, not terrible. Changed it a couple months ago. Evap is decent. There we go. You liked that, didn't you? See that belt flopping over there? Yeah, we gotta adjust that pulley. I heard a spark. We got no fire. Alright, so we're still doing the too flashy thing, huh? Unless that's not my limit switch. Am I mistaken here? Limit switch, violet, LS. Limit switch, oh, it's LSM. But I don't see an LS. What am I missing? I mean, we have a rollout switch, a limit switch. That's got to be that's my only limit switch. Here's my ignition module here, of course, guys. And this is what I would consider our logic circuit. Before the IGC says, yeah, let's go ahead and fire up, it's got to have a properly closed limit switch. So let me look into this limit switch. Maybe it's sort of flaking out, and once it starts up, that vibration tweaks it a little bit and it's not closing. Not real sure. So hold on, guys, I'll bring it back in a minute. Got my pulley adjusted, belt's nice and tight, motor secured. I'm gonna take an amp draw of my motor. Should be about 6.9 amps. I tighten the connections up on this. Again, it rang out, so it's closed. I'm gonna double check it again, and if we continue to have problems, we might just be dealing with a board issue. So let's fire it up again, see what happens. Amp draw looks good. Let's see if we can make fire now. And we got fire. Alright. Well, before it gets too hot, I'm going to wrap this up. And we'll look over a couple other things, just make sure all the wiring's nice and tight. Give it a quick, sort of a quick PM, right? These wires go to, probably noticed, our little I-wave back there. This unit is under 6 ton. This is a 5-ton unit, I believe. So yeah, let me put this panel on, fire it up. We'll get ready to do a temperature rise and see if we can't get them some heat. Designed maximum outlet air temperature, 185. We are at 155 right now. Actually, I know my return is about 70, but just for poops and giggles. Oh, right there, duh. So while we're waiting for our probes to equalize, what I think was going on is my belt was slipping around on the pulley, I'm guessing. It wasn't really loose. There was a lot of belt dust in there, as you noticed, which I can only attribute to belt slippage. And I guess the limit went off at some point in time, which sort of not common on these, I guess, or not common from what I've seen. Usually if I see those limits go off, it's because the belt is physically broken, or it's in much worse condition. But I guess, you know, the pulley is beveled a little bit on the inside edge. I'm going to let facilities know that they need a new pulley on there. They probably won't change it, but all I can do is tell them, right? I mean, I can't make them do it, so. Looks like our return is climbing up to about 70. Supply is about 160 so far. Our amp draw, if you remember, was about 5.8. Real quick, indoor motors, 6.9, 6.7 full load amps. So we are right about where we need to be. About 1 amp less, actually. So yeah, 67. Well, guys, I think we did it. I think we got him some heat, so I'm gonna go ahead and transition out of here, all right? We'll see you guys on the next one. Take it easy, and if you got snow, make sure you're staying warm out there, guys.
In and say, Bill, we test your house, and we like to think in spectrums and ratios. So a blower door where the blower door reading is equal to the square footage. So, Bill, how many square feet is your house?
Roughly 2,100.
Okay. So if your blower door was about a 2,000 or 2,100, that's pretty good. That's like a C+. So it's not amazing, but that's oftentimes enough where HVAC alone can fix things. Where the odds are we'd test your house and it would be a 2-to-1 or a 3-to-1 ratio. So you'd have a 4,000 or 6,000 blower door. Until you test the house to know what that is, you don't really know which direction is the correct direction.
What's up, guys? So I got Nate Adams outside right now. About to do a home performance test on my 127-year-old farmhouse. I am ill prepared. I'm just getting a couple things set up so I can record this whole process for you. All right, let's go see what's going on. All right, guys, I think they're here. Somebody just pulled up. Oh, and I forgot to do dishes today. Holy crap. I think that's them.
What's left open? What's up with this? What's going on?
See, this is why I need somebody to do a home performance test. I don't know why my house is so drafty.
Your front door just opens.
Actually, yeah, because the door doesn't really close unless you put the deadbolt on.
There you go.
So what's up, guys? Everybody, this is Nate Adams.
Howdy.
And Adams Nate. You're from Cleveland.
Yep.
And Adam is from Chicago. They drove all the way here today to do some stuff to my very old house that you guys are going to get a tour of. So, come on in.
All right, let's
What is
go.
your damn cold out there?
It is nippy.
It's a bit nipply out. Yeah, this lighting is awesome for videos.
Yeah, we should. Let's open up. Let's get as much natural light in here as we can.
See, if I really knew what I was doing in the YouTube world, I'd be prepared for this.
No, don't worry about it.
Yeah,
This is why we're all here.
your floor is cold, I'll tell you that.
Yeah, I am not liking standing on your cold floor. That's sucky. But this house is a beaut.
See, this is why I want to do something to my heating system.
I'm curious just how leaky she's going to be.
Oh, she's gonna blow her test off the charts.
Heard for particle count, it actually a lot of them like estimate.
They're talking about lasers.
Sensors and that. So this is actually measuring particle.
Yeah,
count.
this is measuring the particles going through the laser beam.
That's awesome.
So that's the
Right
most
there.
accurate.
That's Nate Adams. He's gonna whisper to my house today.
Well, I won't whisper to you though.
He's gonna whisper sweet nothings to us. I tried calling you too on the way here.
You try calling me?
You. Yeah. Check your missed calls.
Interesting.
Because I was calling because I was up at McDonald's. I'm like, man, I might run late.
I got your.
Nate's going to the other room because he doesn't want you to see him eating.
Exactly. Well, I'm done.
What
This is my book, for what it's worth, but it's full of lots of pictures, and the
So now this book you put together specifically for this HVAC 2.0 system, correct?
no, I didn't. I wrote it because I thought it needed to exist. So this is basically building science 101. So what drove me nuts was I was reading a bunch of like Alison Bale's stuff,
House.
and Joe Stebrick.
I would buy this book just for that cover.
Well, I'm giving it to you, so
Nice.
I'll sign it for you here shortly.
Nice.
But all the stuff that I saw on building science, it was really complicated. So there was no way, if you assume that you know nothing about building science, but you're an intelligent person, there was no way to get up to speed. So I wrote this to do that. And then ironically, the second chapter in it, not the first, that's HVAC 101, that has become the sales tool. So like Adam, anytime you talk to somebody, email them a copy of that.
Okay.
Man, I get
I don't care how you
volts
touch
in my
them,
house.
give them a copy. Pressure we actually get the house to, but normally it's 50 pascals is the pressure that you depressurize them to. So when you do zonal pressures, if it reads 0, it's all the way inside the house, and if it reads 50, it's all the way outside, because you're creating that pressure difference with the blower door.
So you're pressurizing the house,
Depressurizing.
or no, depressurizing the
Somehow,
house.
Yep.
And then if you do the zonal test, like you close the door, and it should pressurize to where it was before.
Well, it'll help you see how leaky that room is. It's not a perfect number by any means, but it gives you a good start baseline.
It'll show it's, if you shut the door, it will show it's a little bit less leaky.
Yeah, well, it'll show you how close to outside and inside it is. So, like, if this house was a 2.5 story and it didn't look like it was from the outside, but say you have a third floor, you got sloped ceilings and all that. The attic spaces up there are almost always a 25 pascal. They're right in the middle, which is 50-50. It's half in, half out. So I don't care if something is in or it's out, but it has to pick one. And so the zonal pressure helps you understand, like if you check a room and it's 10 out of 50 pascals, that means it's 20% connected by pressure to the outside. So 10 divided by 50 is 20%.
Not sure why it's so confusing.
Yeah, I'm sorry. So the key thing is it helps you understand, is it inside or is it outside, and by how much? And that gives you your starting point so that later, if you do a bunch of upgrades, you can check that room again and see how far you got it down. And at some point, you're just like, that's good enough. I'm not worried about it.
Yeah.
Because nothing's ever going to be completely in or completely out. Like that's unrealistic.
Do you like block off or tape off the door, or you just shut the door?
You just shut the door. Like it's not like it's perfect, but it's a
Right.
repeatable test later.
Yeah, like here, I have a door like right upstairs, like right at the entrance to the upstairs.
Oh, sweet. So we can close the whole second floor?
Yeah.
All right. That's going to give us a really big difference. So
Okay.
that'll be good to find out.
Cool.
And this basically just helps you understand where are the big problems. So it's just a diagnostic check like you all are used to doing when you go find a broken piece of equipment. So I don't even know what the measurement is. When a capacitor's bad, what are you checking?
Microfarad.
Okay. So you have an idea just by pulling that measurement if it's shot or not.
Yeah.
And so this is kind of a quick and dirty. There's lots and lots more diagnostics that you can do, but the Comfort Consult is mainly about relatively quick and dirty diagnostics to help understand. So what's the path? You know, we can go this way or we can go that way, and this helps us decide which fork we take. It's not the complete diagnostics process. It's
Yeah.
just pretty good.
It's not like this is your smoking gun, fix this, all your problems go away.
Exactly.
Yeah.
In houses, they're so complicated anyway that we find a lot of people are going around and like, well, I got my little trim nail hammer, you know, dink, 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 dink. Let's see if that fixes it. It's like, sledge.
Yeah.
So it's just, how many times are we going to hit with a sledge is basically what it comes down to.
I only want to hit it a couple times.
Well, ideally, if you do it right, you do it once and you're done. You don't have to think about it anymore.
Well, kind of segueing, see. So Over here, my old plaster walls, you seem to think like the outsides are like drilled and then foamed in, you think?
Or probably cellulose.
Cellulose
is what they used.
Is it cellulose? So that's not like spray foam then. Cellulose is just like that.
It's newspaper. It's 85% newspaper.
Oh, so like I was telling.
15% fire retardant.
Who was I telling? Was I telling you that I was going to stuff my walls full of Kleenex?
Yeah, that was me. Yeah, you were messing around.
So I wasn't very far off.
Not at all.
See, so they really are basically stuffed with Kleenex. So in order to like better insulate the walls, and maybe we can get into this later, but I've often wondered if, because I'm going to have the house re-sided at some point and tear off all the layers.
Oh, okay. You're going to get rid of the wood siding?
Yeah, like, I don't even know what's underneath. Like, there's wood over here, aluminum over here, and then asphalt shingles underneath some parts of it.
Yeah.
So I don't even know, like, what's underneath that.
There'll be wood underneath it.
Just like...
Most likely.
Yeah.
Well, just like the little bit that's on your front porch.
Yeah.
It should all look like that underneath. Somewhere.
Interesting. So, take that wood off?
Maybe.
Or just put foam over.
So that's a solution.
Yeah.
There's a lot of different ways that can go that depend on your budget. That is an ungodly expensive project there.
So, to take the like the boards off?
I mean, if you're going to take all the boards off and then resheathe the house,
you're probably not going to do that. I mean, I got a budget.
And then reside, like that's $50,000 if it's a penny.
$33, yeah, something like that.
Yeah. Up to and including $43.
See, I was under the impression that when you leave, Nate, all of my problems will be fixed today. Is that not how it works?
You didn't read the email.
I didn't read that book either. Yeah.
And this is why you send emails to what to expect.
That's right. Take a look. It's in a book.
And if you didn't read it, well,
there goes my hopes. I told my wife all our problems are going to be fixed today, so I guess that's not going to happen. So
hopefully she's smart enough not to believe you when you say something like that.
Well, I will not respond to that comment right now.
All right, so order of operations, at least we probably just want to do like the comfort consult and run you through everything.
You know what I forgot to do? I forgot to read that thing you sent.
What, HVAC 101?
That whole thing. Yeah. Damn it. Should I have read that?
Yeah.
Can you give me like the 10-cent quick tips? So this is your badass HVAC software.
With badass HVAC right on here. Yeah, so this is just HVAC20.com. And you
ever think about changing the name to The Donkey Show?
Just for you, Bill.
Should.
Just for you.
We can upgrade you to The Donkey Show.
So it just, because I logged in a minute ago, it just popped me right in. Thankfully there's no actual client showing except for myself at the top.
Okay, so don't worry about editing that.
Yeah, you don't have to worry about that. Like I don't care if people find my address, whatever. We'll get you in, Bill. Are you a current client? No. So we set this up for CSRs. It's not perfect yet, but it's at least a good start. What's your email, Bill?
CuriousHVACguy@gmail.com.
Let's see.
So now this is something you fill out on for every customer?
Yeah, for every customer you want to fill this out.
So you're essentially just setting up a profile, right?
Exactly, yeah. But this does have the 4 questions in here that you can ask people. It doesn't do quite what we want very well just yet. But this is it works. So here's these are the 4 questions as we call them. We mentioned them earlier. So parts of my house are uncomfortable or sticky in the summertime. Is that not a problem or a big problem at your house?
Yes, it's a pretty big problem.
You don't have air conditioning, so.
Yes.
So on a scale of 1 to 10, where are you?
I'd say probably like an 8.
Great.
Yeah. So we tend to stay pretty comfortable somehow with the shade and
lots of thermal mass in the house too. It probably takes a while to heat up.
Yeah.
These big old houses
cools down at night, and all the plaster in the walls absorb the.
Yep, it's like an adobe house.
Yeah. Or not really absorb the cold, more or less release the heat.
Release it. Yep. Parts of the house are uncomfortable or dry in winter.
Yes.
1 to 10.
I would probably say, I mean, it's not terrible today, like probably 7.
It is nice you have the radiant for that. That helps a lot.
But if we're talking uncomfortable because of like temperature, then you're talking a little bit higher. But the dryness factor doesn't really affect me too much.
The temperature is what I care about more. I just put that in here to kind of mess with people's minds, get them thinking about it. So should you be an 8 for wintertime?
I would bump that up to like maybe even a 9.
Okay.
Just because we have such a variance of temperature between each rooms and floors, and
you don't have radiators in some of the rooms. Yeah. That sucks. No wonder you want to change stuff out.
Yeah.
So then are there any health concerns, allergies, asthma, mold issues, lots of dust,
No.
pests? So is it a 0?
Yeah,
or?
That's a 0.
Okay. Then are there any moisture issues, mold, mildew?
In our
standing water
bathroom, we have a little bit of mold issues, but I'm pretty sure it's because when we take showers and whatnot, all the steam and everything just condenses on the walls.
You don't have a fan.
No fan? Okay, yeah, there you go.
The fan broke, and I've been meaning to replace it, but it's some sort of funky fan that I have stuffed up into the ceiling. And
this has an automatic scoring tool in it. So see, your score is 17, adding up those out of possible 40. 4 questions.
You didn't give him a score on the mold.
Oh, I didn't. No, you're right. Thank you. So scale of 0 to 10, mold moisture problems in the house. What would you say?
Right, 3.
Okay. So 3. So now you're going to be at a 20 score.
Sweet.
And like this is kind of fun. Here, I'll just go play with this. Let's just turn this down. So now it'll suggest a free quote, where before it had a comfort consult. But like I can play with this.
You would probably want the husband and the wife together for this.
Yeah, we should be doing a 2-legger, so we're not.
Yeah, it doesn't matter what she thinks.
Well, you won't get quite as much value, but you're going to learn most of what you want to learn.
Okay, I'll play
the
the video.
Watch what happens here. So when you go above 12, or actually, look at that. So right there. So if any of them has an 8 or higher, it suggests a comfort consult. So that's how this works. Because like if any one answer is high, you want to lean them in that direction. But this is meant to be a tool, so very soon this will be embeddable on a website.
Oh, that would be awesome.
So then they can go do this, and they can play with it and see what happens, and they'll learn the logic behind it.
So with the free quote, what is the free quote? Just like you have this system, we'll just replace the system.
Like for like, let's just
like.
change it out. We'll give you the option for a couple different things. Buy what you want, but no consulting. So hopefully it should avoid you having to do a bunch of the song and dance that is traditionally part of quotes. So they can pump you for a specification, and then like once you give them what you want and all this stuff, and you give them a price, they go to the next guy. Can you do this for cheaper? That's really frustrating to have happen.
Well, I mean, do you actually give them, after you do the consult, like all the data? I mean, they're paying for it. Do you give them all the data where they could just walk away and do with whatever they want with it? Yeah.
Yeah. You want to do that though?
I just in the past when I was doing, load calculations, the customer would be like, well, can I see the load calculation before I sign up with you? I'm like, no, pay a deposit and I'll give it to you. And
so,
and it's like well, I'm not going to give you my work for free, you know what I mean?
So most people are charging $300 to $500 for what we're going to do. So as soon as you have somebody pay you to do work, now you're not a salesperson, you're a consultant. So you just flip the switch in their mind as to what you are. So you're going to give them a complete specification of the load calc and everything. They can do what they want, but write your specs so they're hard and they scare people. And then they'll get fear pricing from other people. Because I had this happen a while ago. We had a $14,000 budget for doing a green speed. And my client went off the reservation. This client has done this a bunch, actually. He's always breaking what he's supposed to do. And so he goes and just gets a bid from some guy. And the bid came back $23,000. The guy was terrified of my specification and the fact that I was putting a heat pump into a 2,700 square foot house.
So did he overbid it to get out of the job?
Yeah. It was screw you pricing or fear pricing. But my client got it, and he's like, Nate, what the hell? Like, I'm not going to pay this. This is stupid. This blows the whole project up. I'm like, did you call somebody that I asked you to call? No. Let's call them. 13.5. Done. I mean, I have to, part of my job is to have an idea where the pricing is. And as HVAC contractors, this process is mainly going to sell HVAC. So I would expect that in like 95% of situations, you're going to sell a piece of HVAC and probably no shell work. So it won't move to the CPP, the advanced audit piece of it. So this is a sales tool to help you work your way up and sell them a nicer piece of equipment that will lead them to be a happier customer, and you can make a higher margin. So everybody wins. But you have to build value. This is all a value building exercise.
I mean, I think this, to be able to embed this into a website would be huge, because the people could it's not like I'm sitting behind a computer and this is spitting out towards you. You're entering all your own data, and it's telling you what you need, you know?
I mean, depending on where you are, it'll lean you one way or the other. So with a score as high as 20, it's just going to suggest a consult. But if you're like at a 10, it'll say either one could be fine for you. Or if you have any one score that comes in 8 or higher and you saw it do it, it flips to recommending Comfort Consult.
Right.
But this is offering people stuff. They shouldn't feel sold on this. It's like, look, you use your numbers. I don't care what they are. Use yours. And they end up landing themselves in a Comfort Consult. So you scored a 20, my friend.
That's
pretty bad.
I thought 20 was good.
No, it's a maximum of 40, but really once you start getting over about 10 total on the 4 questions, so there's 4 questions, maximum score of 10 of each, so maximum score of 40. But if you have a client that scores, more than about 12, they usually have something to fix in their house. So this will lean them towards a Comfort Consult. Does that make sense for you too, Adam? Because there might only be one thing that's high. The other thing is if there's anything that they answer 8 or higher, it'll just recommend a Comfort Consult.
Just right off the bat, Comfort Consult.
Because you got something that's really screwed up, and this is trying to measure client pain. So stuff that bothers them that they're willing to pay for. Because pain is distinctly related to money. So if there's something that bothers them, they're going to pay something.
How much money do you want to pay to be comfortable?
Exactly.
To get rid of that pain.
Exactly. So this is helping them understand that, whether or not they fully understand what's going on yet. But so if they answer all 2s, great, just do a free quote. We'll just change your equipment out. And what we're seeing is it's running about 70% free quote and 30% Comfort Consult. But because you don't have to do all the song and dance in the free quote that you normally do, because if they start asking you a bunch of questions, well, maybe we should do a Comfort Consult because we want to cover all that stuff and make sure we do a good job. So you can stop them from their asking for free consulting and convert them to paid consulting. Or it's just a fairly quick in and out, let me measure your ductwork, see what size you got, and you give them a price.
Interesting.
So it should have the time of a free quote, and then that time would end up getting applied more to a Comfort Consult. And the Comfort Consults do take a while. I mean, most people spend somewhere between 2 and 3 hours on a free quote when you consider drive time, being on site, and writing stuff up.
Oh, what was it, last year? I had 3 companies come over and give me estimates on replacing my boiler with a forced air system and doing the ductwork. And I think the longest the guy was here was a half hour.
There you go. Well, he was going too fast. So
nobody had a tape measure I think the one guy might have had a notepad. But they all quoted me basically the same thing, and they were just in and out. And the prices were just, actually only one guy even gave me a price. The other 2 guys never even got back to me. Yeah.
Well, it was a scary job. You made them nervous because this is not an easy thing to do.
No.
And I noticed that you haven't bought a forced air system yet a year later.
No, not yet, because I haven't been satisfied with, I guess, what I actually need. Because everybody's like, oh, you need this. But I'm like, yeah, but you didn't measure anything. You're just looking at my house. And I'm like, that can't be right. When I go buy tires for my car, they look at the tire. And
But you need this tire. I'm like, yeah, that makes sense. Like, you come to my house, you look at it, but you don't take any measurements.
That's bullcrap.
Mm-hmm.
So, yeah, a situation like yours definitely needs more. And there's plenty of people out there that need more than a free quote, too.
You should have a question there, like, how cold is your toilet seat? So mine is very cold. Uncomfortably cold, even. So
Really
if you can
chaps your ass? Is that what you're saying?
You can add that to your software, yeah.
We're trying to keep it to 4, Bill. So the big 5th question is, how cold is your ass when you sit down on the toilet?
You just put that idea in the back pocket there. You might need that someday.
All right, that might come out. There's millions of dollars sitting in that one.
Run it by the board and see what they say.
I'll buy you some beer if that works out. Okay.
I'll keep it in my fridge till you guys come back around then.
This whole thing is set up to be a script. So the Comfort Consult requires 3 things. You need to be reasonably good with other human beings. You need to be able to read a script. And you need to be able to run a blower door, which I can teach you in an hour or 2. It's not a hard thing. Anybody that's mechanical, if you can't figure out a blower door quick, then you shouldn't be in the HVAC world. They're not that hard. So the whole thing's a script, and like everything in gray here, these are the tips. Mm-hmm. So you would read this ideally before you get there, but it helps give you tips of what to do.
Talking points forward.
Yeah. It's telling you like
behavioral cues.
Yeah, what you're supposed to be doing, how to think, where the client probably is. So you answered incorrectly to this first question, by the way, Bill. Did you get the email with the ground rules?
Oh, I got it.
Yeah, but you didn't read it.
That's right, but your question doesn't say that. I got the email. It didn't say, did you read it, though?
I'm saying no. Did you? Okay, so I'm going to change that because of you.
You should.
So, cold toilet seat, and did you actually read the damned email?
It's a loophole I just found in your system.
And then we'll ask people, like, did you read the chapters? Although we were sending 2 chapters to begin with, but it was too much. And so we backed off to just HVAC 101 because it's 16 pages. It's relatively quick. And it's a sign of interest if people read it. And then you just go into, there's a whole spiel here. But this is the goal for today, which is to figure out what are your goals, what does your house need, and what is the budget. Because if we can't get those 3 circles to cross each other, we don't have a job.
Now, how deep into, I know obviously you can't get into specific costs for a budget, but do you, I guess, delve into like even a little bit of the budget? Like,
at the end, we
approximately how much it's going to cost you to do this, this, and this? So
that's an important question. There's 2 different ways to look at the budget, and we choose the one that homeowners usually aren't expecting. So there's what things cost, and there's what they're worth. This is trying to figure out what they're worth, because it doesn't really matter what it costs. We routinely have our guys get budgets of like $3,000 back for HVAC. It's like, congratulations, it's $8,000 for the cheap stuff. Wow. It just is.
Yeah.
But this is more about what it's worth. So like, I'm sick and tired of dealing with this, and we move people to think in monthly costs. Because if you ask for a capital number, it's almost always $5,000 or $10,000. It just kind of is. And for the bigger projects, that's not enough. And even for nice HVAC, that's not enough. Like a nice inverter system, they start at $10,000.
Oh yeah.
If you're lucky. So that's not going to get you there. But if you have them think in monthly, like, and we'll get to the question later. Michael Hausch came up with this wording. It was so if you were renting this house, how much extra would you pay in rent to make those problems go away? And most people will cough up $100 or $200, and $200 works out to $28,000 over 15 years, with 4% interest, so like a home equity line of credit. So they don't realize that they just gave you $30,000, but later when you help connect the dots, they can understand what happened.
That's a good way to put it.
Monthly. And then if they push you on like, well, how long is this for? Like forever. Like don't give them a term. Even though we're thinking 15 years, don't tell them 15 years now. Just like for as long as you live here. Even if it's until you die. And that tends to, it helps break them loose because they need to be thinking about what is it worth, not what will it cost.
Yeah.
Because there's literally millions of permutations of what we could do to your house. We need to narrow it down to like 3 or 4.
Yeah.
So that you can actually make a choice.
Viable things we can do.
And so what the house needs, what your goals are, and what the budget are, basically comes together to create that chute. So we actually know what's going to come out the other side.
Mm-hmm.
So that's the whole game for today, is to begin to sketch these out and see if there is a viable project in the middle. Does that make sense?
Yes.
All right.
Yep.
Okay. So you get the basics there. This is today's job. Figure out what are your goals, what does the house need, and what's the budget, and do we have some prayer of making those overlap. So the rest of this is largely just kind of a little presentation, because typically there's one spouse that got you there, and the other spouse you asked to be there, and they're not happy. So you want to bring them up to speed. And here we are doing a one-legger. Come on, man. Come on.
She'll be at home at 4, but that's not going to help us.
No, it'll be fine. We'll be on the blower door by then.
She doesn't care about the home heating system at all. Not as much as I do. She's like, whatever, just give me some warm pajamas.
Well, then you're lucky in that, frankly.
Mm-hmm.
She doesn't cost you a ton on that. So this is the order of operations we'll do today. So a little bit of education. This is, again, getting both people up to speed. We'll clarify goals. There's a lot of questions. There's an hour's worth of questions. We'll take a look at the HVAC. We'll run the blower door test. Then we'll sit back down and we'll prioritize the goals and put a budget on the whole thing. And again, this budget is what is it worth, not what will it cost, because those are two separate things. And then we'll talk about next steps. So here's the basic building science education. So stuff that you want to solve or any clients want to solve fall into these 4 buckets. So there's either comfort issues, hot and cold rooms, health and safety issues, carbon monoxide in the basements, kids with asthma, allergies, things like that. Durability is all about moisture, things that are causing things in the house to fail. And then the last one is efficiency, and this makes a really bad goal. So these are actually worth something to people to fix. Efficiency, as soon as you bring it up, people are like, so does it pay for itself? No. Like these projects have paybacks in the centuries, usually.
Yeah.
Because realistically, you're paying maybe $1,500 a year to heat this house. So even if we can knock $750 a year out, fully half, which would be absolutely heroic to be able to do something like that. A 10-year payback maxes the project at $7,500. You can't even buy HVAC, let alone ductwork.
No, definitely not.
So there's no payback, and so that's an unreasonably high amount of savings, and an unreasonably low project amount. There is no payback on this. The payback is your house is comfortable. Mm-hmm. That's basically what it is.
I can live with a little bit more happiness.
Exactly. So there's 3 things to control. So you want to be able to control airflow, heat flow, and moisture flow. This is the physics of how the house works. And the most important of these by far is the air, because heat and moisture travel on air. Mm-hmm. And then there's 2 different ways we have to control this. First, we need to control air, heat, and moisture going in and out of the house. So that means the house has to be relatively tight so that it's not just open. Right now, your house is going to be like this boat, like for sure. Like if this house was a boat, it would be on the bottom of Lake Michigan. That just is.
This drawing alone should be good enough to get people out of the mindset of like, well, just replace it with whatever was in there before.
Exactly. Yeah. Well, we got to test and see if is this a problem? Mm-hmm. And if this is a problem, do we want to deal with that? Because the house as it stands and the house once it's upgraded will require 2 different pieces of equipment in most cases. So if you replace the HVAC now and then do your upgrades, the equipment's going to be wrong enough that your comfort's going to be bad again. Mm-hmm. And then if you want to fix the comfort, you have to replace the equipment again. So we'd rather size a house to where it's going, not where it is.
Yeah. And
so the load calcs we run for this show where the house is and then where the house would be with reasonable upgrades.
So you might even run into a situation where like eventually the house is going to be at this level of tightness. So you're going to need almost like a smaller system. Whereas right now, if I were to upgrade it, I'd be like, well, you're going to need an 80,000 BTU furnace. Yeah. And then that's for right now with it leaky as it is. Mm-hmm. So that makes sense.
Yeah, and so if you did an 80K, that's usually a 4-ton drive, so it'd probably get a 4-ton heat pump or air conditioner on top. And probably a 60 and a 3 would be more appropriate. Or if you get the house tight enough, a 3 or 4-ton heat pump on its own may be the right piece of equipment.
Interesting.
So it just depends, but you want to understand what is the spectrum there. Here's the house now. Here's where it could be under absolutely ideal conditions. Here's where it could be under achievable conditions. And then you can make an educated choice of your HVAC system. So the second piece of controlling air, heat, and moisture is inside the house, and that's obviously the job of the HVAC system. But first we have to see, is the house leaky or not? And like if you have a leaky boat, are you going to replace the bilge pump or upsize the bilge pump?
No.
It doesn't really fix anything. We got to fix the leaks.
Yeah, you're definitely going to need one of those little floaty keychain things.
Yep. So it's funny, I'll probably be changing this slide out as we move forward because this comes from, my background is more insulation than it is HVAC. So HVAC has been a really hard freaking thing to learn. The last 4 or 5 years have just been intense trying to figure this out.
I'm trying to learn it myself.
It's not easy. And the deeper you get, the more you realize you don't know. That's insane. So these are the 5 priorities of home performance. So if you want a house to work right, I was having trouble getting the point of air sealing across. I don't have that trouble anymore. I don't know why.
Should I air seal?
No, you should just go right to HVAC. Yeah.
Let's just upsize it. Give me a furnace the size of a semi-truck.
So this still basically applies, but you may test a house and find out that the air sealing and insulation are good enough. And about half the time, it's close enough. Like you could do more, but the nice thing when you get a newer house that's relatively well insulated and air sealed, the right piece of equipment today and after upgrades is the same piece of equipment. So it's not a big deal. It doesn't really matter. It's like, okay, let's just put this size in and we're good to go. Houses like yours are hard because it will be 2 different pieces of equipment for where the house is today and where it would be.
Once it's air sealed.
Yeah. So this is the way that it works, but we're surprised by how many houses can skip this. Because in our practice, we only have the bad houses find us. So we're like, oh, they're just all bad. Look how bad all these houses are, because all we get are the basket cases showing up at our door. But in the HVAC world, you're dealing with the public. It's everybody that shows up.
This alone makes me glad that I don't do residential HVAC. Because the amount of, in the commercial world, we don't have, like, you can't go to the owner of a dollar store brand or whatever and say, hey, we need to blower door this store. And like, for what? I don't give 2 craps about anything.
Just change the equipment.
Yeah, just put a bigger one up there. I don't care. I don't even have to. So this whole world is new to me.
Well, it's good if you learn a little bit of it. It still cross applies. So my partner did a commercial building. It was an office years ago, and he ended up using residential equipment. He did 2 green speeds on it, and it was an Energy Star certified building, or maybe it was LEED. It was one of those. Actually, it was LEED, and the energy use on the building was so low that it was actually below the modeled range. And they said, if you actually want us to certify it LEED, we need you to get your energy use up like 5,000 kilowatt hours a year, which was crazy. So they can work really well. This is basically a good way to look at the mindset of how we look at projects. So this red line here is what we call low-hanging fruit thinking. So over here, this is stuff that happens. This is benefits and results. And then the other axis is work that you do or money that's spent. So it's, work and results. And typically what a lot of people think is when it comes to fixing stuff in the house, I'll do a couple of things and it'll make a huge difference, and then doing anything more doesn't matter. So everyone's trying to optimize for this point over here.
Yeah, right at the curve.
Yep. But the problem is, the reality is houses move like this. The first couple things you do don't change much, and then they start to really move. So where you actually want to optimize for is up here, where spending more money doesn't bring a lot more results. And the issue here is, with most people shooting for here, they actually get here. That's the reality. So the whole process in HVAC 2.0 is trying to understand where is this point. And on a lot of houses, it's basically we just need to put the right piece of HVAC in that's small and variable speed, and most of the problems go away. But then if you have an old leaky house like you do, there's probably more stuff that needs to happen. But it always cracks me up here when somebody's like, oh, we can fix this problem. They're like, ding, 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 like tiny little hammer. It's like, we need the sledge.
Yeah, you're not going to fix it.
Yeah.
I can't spray foam like I wanted to.
No. That's just for annoying Corbett Lunsford.
Which is okay because he's not watching this video.
He'll hear about it. So this is that same curve looking at it a different way. So we think a lot in odds of success. So houses and buildings are complicated systems of systems. So you can't just do one little thing and have it actually move the needle. So you want to be thinking more like a doctor. It's 50-50 odds, it's 80% odds, whatever it might be. And what we want to try and design for is to get above 80% odds of success. That's a lot of what we're thinking here. And the issue is traditional contracting is usually playing in this little bit here. And then there's other systems, like I love the passive house system. That's I joke, there's difficult, there's insane, and there's German. This is the German standard passive house. And it's crazy efficient, crazy tight, but it just isn't achievable for normal people. Like turning this house into a passive house would easily be $500,000.
Wow.
You're not going to do that.
Nope.
It's just not going to happen.
Out of my budget.
But we don't need to be going off over here. We want to find the sweet spot.
Yeah.
So
yeah.
What we're trying to think about is get enough measurements, enough of an idea to be comfortable that we're going to be in the 80% or higher odds range. That's what we're trying to figure out. Does that make sense? So it's just a big diagnostics process. And that's it for the quick little intro. And then we start with warm-up questions. Because if you go straight into pain questions, it's too early. You need to get through the pick this up, stick it in that side.
Which side first?
Yep. And you put a foot on the bottom, and then lift up there. And then you want to tighten the knob that's over there. So I usually I'll pull up on it as I tighten it, so it's kind of snug.
Okay. Same thing over here.
Yep. So kick the bottom in with your foot, and then push up and tighten. There you go. And then you do the top and the bottom. And then I usually kind of just give it a shake test. Yeah, I think it's tighter this time than it was last. Yeah, she's in good shape.
Decent. Okay.
Then you put the fan in. Cool. And now you know how to put the blower on. It's not hard. Putting the frame together takes a couple minutes.
Yeah.
That'll work. Good. And then here's your hose. So you might start with that end and do the bottom first.
Okay.
Yep, yellow to yellow. Yeah, and then the red goes last. That's up high.
Which one does this go to?
It goes to in. I think it says.
What is the out for?
You can put multiple fans together.
Okay.
Because they'll do full building tests running like 30 or 50 fans for giant buildings.
Not bad. Cool.
Nope, so that's that side. And then usually I just kind of put this in here. You're tall enough too, you'll be able to see the top easy. So I loop the red and the yellow back behind and up and over. Yep. And that's how it goes in the bottom of it, actually.
Oh,
It's confusing.
what is the other one for? The same thing if you have the second blower door?
Yep.
Okay.
Or am I wrong? You know what? No, I take it back. It does go, the Cat 5 does go on the top. My bad. I haven't used this that incredibly much. But I only got it right before we went on our trip, and I ran like 4 tests with it. So I'm still new too.
Okay. Good to go.
All right, so now we just got to run the power cord. And I think there's 3-prong right over there. Plug it in. I always carry, by the way, a 2 to 3 converter, because you'll test a bunch of old houses that don't have a 3-pronger. So you want to have the converter. So the power switch is over here. Numbers, I think, in ratios of leakage to square footage. So the house is 2,100 square feet. If it's a 1-to-1, so which would be a 2,100 CFM50 on this.
What is I was trying to keep up with you guys, like the CFM50 thing, because that's like something you guys started, right? That's not a...
Yeah, that ratio, yeah. It's although Minneapolis Blower Door actually had it in their manual too from years ago.
Okay.
It's a really good kind of rough way to get a quick idea of where something is.
Okay.
It's not like the best number in the world, but it's pretty good.
Well, what does that mean, CFM50?
Well, CFM50 stands for cubic feet per minute,
Yeah.
50 pascals.
Okay.
So 50 pascals
That's
is
like the
pressure. We're going
baseline.
to try to get that to.
Okay.
Yeah. I don't know that we're going to be able to hit it.
Right.
So like a 1-to-1 is decent. That's like a B minus.
Mm-hmm.
So like you're definitely not top of your class, but you'll make it through school. At a 1-to-1, fairly often HVAC can control a house.
Okay.
So like if this had a 2,100 blower door, you know, maybe we wouldn't even bother with shell work. We'd just put in HVAC and move on with life.
Okay.
60s and 70s houses are usually in the 2-to-1 range.
Oh,
So this
really?
would have a 4,000 blower door. And this era is routinely in a 3-to-1 range, which
Okay.
should be a 6,000. 6,000 for the hell of it. Do you want to take a guess, Bill?
Please.
Actually, that's an order. Take
What
a
do we
guess.
get to know?
The blower door. So I'm betting that your house is about 3-to-1 from experience. But it may be better, it may be worse.
So you're guessing 3-to-1?
So which is a 6,000 blower door.
Since I am just guessing numbers, not really having any idea of the science behind it, really. I'm going 4-to-1.
4-to-1? Okay, 8,000?
I think it's going to be closer to 7,000 because of this porch.
Okay, let's find out.
I mean, I don't really know either. I've seen this happen twice.
We're all wrong. So we should guess low. We're all wrong. Somebody should have guessed low. Oh, wow, he does have a light. Look at that.
Oh, look at that. So what are we looking at here, Nate?
All right, so this is the zonal pressure of the basement. So this can be a little bit confusing, but right now the blower door's running, and we're creating a 50 pascal difference between outside and inside. So we have this tube running underneath your basement door. And it's measuring the pressure difference between here in the house and the basement. And this number should be under 3, which would be like 6% leakage outside. That's when we get a basement in good shape, we usually get something like that. But instead we're around 13. And if you double that, that's about the percentage connected outdoors. So the basement's like pressure about 26% outside. And this is it's not good.
I feel like that's better than what I thought, because the whole front porch thing.
Well, so that's different. There's insulation and there's air sealing. This is the air leakage side of things, not the insulation. So under your front porch should get insulated because it's not done very well. But this is still a really bad number for the basement. I've seen a few worse, but not many.
Awesome.
So there's some work down there.
Well, good. I'm glad you didn't waste the trip. So the knee wall attic is basically, well, let's just pop it open to take a look.
Here we go, yeah.
Oh wow, it's cold, huh?
Good Lord, that's cold.
Look at those old cedar shakes.
Yeah, see, I need a lot of cans of spray foam for this.
Lots and lots of cans.
A lot of Kleenex.
See, you know,
the Kleenex.
lots of mouse poop in there, but I can't seem to get a damn mouse in one of my traps.
Well, Adam, you want to trade places with him and see if you can get a pressure on that?
Yeah, that just blows it right open.
That's ridiculous.
Actually, I'm going to run downstairs. So that's better than I usually see, ironically.
For a
Why do
knee
you
wall
want
attic?
this?
If it's outside, it'll read 50.
Okay.
And the attic should be outside the house.
Okay.
So you should be heating your cooling.
But it should be better insulated or better sealed, so it's not.
Yeah, it's still not great because it's still 20% connected to the inside.
Yeah.
But usually when I test knee walls, they're 25. So they're half in, they're half out, 25.
So you want that, if anything though, what he would want to do is make sure this wall is sealed and this door has a better door or a better seal or whatever.
Yeah, there's a bunch of different ways to get there.
Okay.
It just takes some more thinking to figure out which way is the best way. And
So that's interesting.
so that's normally what I see in spaces like this.
What's that number again? 24.2?
Yeah.
In the master bedroom?
That's 40.
Now, you're saying that's really good?
50%.
That's 50% connected to the outdoors. Yeah, that's
So our
really
master
bad.
bedroom is like 50%
Outdoors.
outdoors.
Yeah.
So we're almost like going camping every day.
There you go. You like camping? You do it every day.
That's amazing. No wonder I'm so cold.
This one doesn't show.
You just do your best if you can, and if you can't, whatever.
So this one's not terrible?
Well, you can't shut the door, so it's going to be worse than that.
Well, that and over there, underneath that little tub where I think they had a built-in shower at some point in time,
Yeah.
there's a vent that goes behind that. That used to be an old dryer vent. Now, I insulated it really well. I stuffed an old towel into that vent. So
That's really, really well right there.
I'm
Really
pretty sure Corbett Lunsford would be proud of me too.
Are you friends with him? Do you know him?
Who's that?
Corbett?
I like to give him his little tiny house stuff. See, another thing is I have this attic access, if that makes any difference.
Oh, yeah. Oh, you got a random couple of can lights in here, too.
Yeah, I can feel
man.
air moving
yeah,
over here.
it's coming right through there. You
I can feel it
totally
coming
feel
through
it.
the can lights.
Here's sub panel number 2. Oh, look at you. You even dated it.
And I even have a rope ladder in case we catch fire up here.
Woo!
Just so you know.
Safety first.
See, this is where I want to put the other furnace because I got gas hookup, I got electrical. I can go right up through here,
Boom, boom.
run ductwork to all the rooms, drop vents down,
Bada bing, bada boom.
call it good. But there is, but see, like these walls, I think have been like insulated at some point in time. They
Yeah,
don't
I bet
feel
they
as
have.
cold,
Yeah, you're right. Those feel pretty good.
like not as cold as the other exterior walls.
Yeah, somebody took one of your attics and just finished it and made it this, which is awesome.
Yeah, this is
great.
this is what I want to do to the other knee walls, but I don't know if the other knee wall in the master is like really big enough to do anything as far as finishing it.
Yeah, I don't know.
Because it is kind of tiny, but it would be kind of a neat little space to hide my dinosaur collection at least.
Well, you could turn it into a like built-in or something like that.
Yeah,
Makes
open it up.
Nice little space.
Yeah, that's not a bad idea.
Yeah, we'll chat about that.
10.7 bathroom.
Bathroom 10.7. Okay.
All right, so what are we looking at here now? So that's
Your
infrared of
leaky
my floor. So my floor in certain spots, which are the purple spots, is 36 degrees.
Isn't that fairly normal to leak through the floor though? But what we're seeing is the whole sum of the whole first floor in the basement coming through the floor.
Well, maybe we might also be seeing air coming from like the front. It's oftentimes coming like, in between the first and second floor. The air that's coming from there, but it could be coming from all sorts of different places.
Okay.
Like, this house is so leaky that it's just like, yeah, good luck.
Good luck at actually pinpointing where it's leaking from.
This is why we say you get out the sledgehammer, because if you're going to make this better, you're going to just have to hit the house hard. 30 degrees. What air leakage
Alright,
looks
so
like.
we are looking at my attic space and something that Nate calls perfect air leakage.
It's a perfect visual representation of it. See how it looks like fingers coming out? Streaks. That's what air leakage looks like.
42 degrees. I don't know, actually when you get close to the edges of it, it's more like 20, it's basically outside.
Yeah.
20 degrees. Got to those 19.
Nice cold day for doing this. You can see everything.
Oh, look at right
Oh,
there.
geez, look at that.
Yeah.
Yeah, so that is a chase, Adam. That's what a chase looks like.
A plumbing chase or something they
Something
did right
like
there.
that.
Plumbing chase? Yeah.
There's another one right there.
Well, that makes sense. You can see the drain lines. I think you're on that wall cavity there. That line up with that drain line coming up out of the top.
There's some in the corner. Oh yeah, look at around the can lights.
Well, those are easy in LED retrofit kit.
How is that so purple?
Alright, so now that we froze my house and we all have hypothermia, what are we looking at here now?
All right, so we asked questions, and then we did the blower door test, froze your house out, looked at the house in infrared, saw all kinds of crazy stuff. But now we need to prioritize what you actually care about fixing, and that leads us towards a budget. So in prioritizing goals, I don't know that you're going to have a ton of goals from what we've talked about. I mean, your biggest one's probably going to be you'd like to switch to forced air. But sometimes I'll get people that give me 6, 8, 10 goals, and I need to know which ones they care about the most, so that if we can't hit some of them, I have an idea of what I want to aim at.
Like a range to hit.
Yeah. So we like to prioritize goals from a 1, I don't care, to a 10, I don't care what it costs, fix it now, which is no budget. So somebody always has a budget, so 9 is usually the highest that people will give. But in the priorities, and like again, here we are, like there's a whole script for how to do all this stuff. But you just type in like what you want to do. So add a forced air system is the first thing that comes to mind for me. From what we talked about. So on a scale of don't care to fix it now, where is that for you?
Well, if we're doing forced air, should we do forced air before air sealing, you think? Or does it...
This will be overall. So
overall?
Yeah, so just to move to it.
I would say forced air is first.
So is it like an 8 to 7, a 9?
Oh, as far as the scale, I'd say at least an 8. Yeah,
Okay.
definitely. It's been top of mind for quite some time now.
All right, so adding forced air is the biggest thing. It's partly just for familiarity, it sounds like, and not worrying about the water in the house.
Yeah, partially familiarity. How do you say that word?
Familiarity.
Yeah, that word.
Yeah, partially for that, and the other part is because I don't really like hydronics.
So, are you looking for the air quality benefits of it?
Well, no, I take all that back actually. The other reason is because, in my opinion, in order to fix all the cold spots, I think we can do that easier by adding a forced air system or somehow putting a system in rather than like trying to run a pipe with water to my master bedroom.
Yeah.
Without like, you could probably maybe come off of that radiator, come off that loop upstairs, and then go through the wall. But then you got a pipe, just hanging out right through the wall.
So now we're to what it really is. You'd like to have your master bedroom be warmer.
Master bedroom, office, and kitchen need to be warm. Yeah, that's a better way to put it.
Yeah. Okay. I'm gonna make
Edit
them 3
out
separates.
last part in my video here.
So warm up. Master bedroom. That's a huge swing. It was cold in there. So we'll start with the master bedroom. So with thinking of just making the master bedroom comfortable, where is that priority-wise, 1 to 10?
It's probably like an 8 as well.
Okay.
It's sort of what spurred all of this, and then delving into the other rooms as well.
So the office, that's probably a little bit lower. You spend a lot of time in there, though.
Yeah, it's probably getting that up to speed, 5, 6.
Okay. And then have the kitchen be warm.
Yeah, definitely the kitchen.
Does that bother you more?
It's about the same as the office.
Okay, also a 6.
Yeah, I'm not in there as much, but I'm in there enough to the point where I'm like, yeah, it just needs to be addressed.
Just like it to be warm.
Yeah.
So the biggest thing is you really want the whole house to be much more even in temperature.
Yeah.
And comfortable.
What?
Like, do you wear slippers much when you're in the house? I mean, I know you're in them right now.
No, just sandals.
Well, okay, so you wear sandals usually in the house, though?
Mm-hmm.
Is that against the cold floors?
No, mostly just because the floors are so hard.
Oh, okay.
Yeah,
Okay.
nothing to do with keeping my feet warm.
Okay.
Like right now, my feet are freezing. I wish I had slippers.
My feet are cold too.
Yeah.
We're getting cold feet. I'm trying to think. Was there anything else that really stood out? I'm going to put it on here, but reducing the mold in the bathroom upstairs.
Oh, downstairs.
Downstairs. Okay,
Yeah.
Downstairs bathroom. I don't even know how much that even ranks. Is that like a 2 or a 3?
Yeah, probably 2.
Okay. So yeah, so it really just comes down to you'd like your house to be warm everywhere, if at all possible. So moving on from that to the next question, which is a budget exercise. Are there any other objectives that come to mind? Any goals that you have for the house?
No. No.
There's more insulation, but that's almost like a separate thing.
Yeah, that ties into those first goals, I assume.
Yeah, because it's going to take some budget to do those. So this was our budget question. We'd like to just kind of bracket people to give an idea of what's going on. But the question that I asked you earlier, so if you were renting the house, how much more in rent would you pay per month to have the house be totally comfortable? So would it be $700 a month? Probably not, but it's probably more than 7.
More than $7 a month?
Mm-hmm.
Yeah.
So what would that number be?
$300 a month at least.
Okay. So that means it bothers you a fair amount.
Yeah, comparatively to what I know I could like rent this house for, what I bought it for, versus like if I move down to the street to one of the houses that are for rent that I know has forced air and is comfortable, versus what I pay now for the the mortgage.
Mm-hmm.
Yeah.
So $300 a month buys about $50,000
Nice.
over 15 years. So that's enough that you've got a project, if you want to. So, but that's the basic idea. Okay, that is it. at that
Nice.
point. So from here, I'll compile a report and send it to you
Okay.
with some recommendations that will mainly be HVAC, and then we're going to run a load calc live here for you.
Do people ever ask you like, well, you're asking me how much per month this is worth? Do they ever become objective about saying that, like trying to think that you're going to just spend the money or whatever, or are you just trying to and how do you address it? You say like, I'm trying to figure out for what you need the biggest fruit that I could, the low hanging fruit. I want to achieve the most I possibly can with your budget. Like,
So this isn't so much about what are we going to do. This is about what is it worth to fix the problem. So you might have told me $50 a month, and I'd be like, yeah, go pound salt. Space heaters and a window unit, and stop whining. That's not a real problem.
So this is kind of like a scratch and sniff test to see like, are we even on the same page?
Yeah, exactly.
Okay.
So ideally, when you're doing this, you have left your sales hat in the car. That's part of why I don't like to talk solutions in these, and we strongly recommend against it. Because as soon as you start, well, we can do this kind of equipment, or we can do this kind of equipment, you quickly find yourself in sales mode, getting excited, and then their walls go up. So this whole process is meant to have everybody's walls be down. And this is an awkward question, and a lot of people do fight it. And it's okay, frankly, if they fight it for the comfort consult. We originally built this for selling the full retrofits, which is kind of what this house needs. So this is a candidate for the full retrofits that we're good at. It's not an HVAC only house. If you had tested a 2000 blower door and it was halfway decently insulated, be like, okay, we're just going to do forced air and move on with life.
So how do people fight that question usually, and how do you combat their?
It's tricky, but the best line seems to be, so remember how I told you I left my sales hat in the car? Like, I don't care what this number is, and if you really don't want to give me one, that's fine too. But this is part of what you paid for. If you remember the Venn diagram at the top of your goals, your house needs, and your budget. So if you want to let me off the hook on doing this part of the work, I'm happy to, but you're still going to owe me the same amount. Do you want to let me off the hook? And if they do, you're done. And if they don't, hopefully they'll understand at that point, look, I'm really not trying to sell you something. I'm just trying to put everything in a line that bothers you. And we now know that your house is really leaky. So like it's going to take some real work to make the house right. But we can. So now it's a question of
what's it worth?
Yeah, what's it worth to you? So what's it worth and what does it cost are two different things. Sometimes they line up, sometimes they don't. Your budget, that may be more than you need, or it may be about right. Like I could kind of see either one of those happening. But there's a bunch of math that has to be done next to decide that. But for now, that's a good number. And like if they gave that to you for HVAC and you were just going to put 2 systems in, relatively simple systems, that may be more than you need. Because if you're going to do some simple ducted minis or like single stage furnace for the basement or something like that, that's not a crazy expensive duct install. So 50 grand would surely do you. 30 might. So anyway, that's the deal. Priorities and budget are how you end the comfort console.
Nice. Seems pretty simple.
That's the idea.
All right, guys. That wraps it up. A day with Mr. Nate Adams and that guy, A-Team Adam, the 2 Adams right here. Now, just so you guys know, this video was filmed safely. All of us got rapid testing. At least I did last week. Nate did earlier this week, was it?
Yep.
And then Adam, he got rapid testing, probably in an alleyway behind a theater before he got here. Point is, we're all being safe. We're not wearing masks, as you can tell, but we all passed our tests, so no hate, all right? Big thanks to Nate and Adam for showing up. Super fun time. Hope you guys enjoyed the video. If you have any questions or anything, hit me up. Email is going to be down below. You guys all know Nate. I'll put a link to his email down below as well, all right? We'll see you guys.
Later.
here somewhere. Ah, there it is. What's up, YouTube? I've been looking for you for a very long time. I don't know what happened, but shit, I just found my phone. So, what do you say we get back to making some videos, huh? So, quick update. I've had some recent life changes, switched careers. Not really switched careers, but a new part of the industry. Working on some bigger stuff. Now, this mechanic room is abandoned. It just looks cool, so I like to hang out here a lot. Sometimes, if everybody leaves before I do, I like to stay here. I like to sleep here. I bring a change of clothes. I just lay on the floor, take a nap, you know? Just because the more I'm in here, the more information I'll absorb, right? That's how it works. We got all sorts of old stuff. Like, look at this thing right here. Look at that giant hunk of freaking metal, man. Look at that. Some sort of compressor. Massive, dude. See, this is what I'm into. This is some of the bigger stuff I'm into now. Now, one of the reasons that I haven't been making a whole lot of videos, not because I just found my phone in this pile of crap over here. That's not the reason. Part of the reason is because I'm still learning all this big stuff. So I figure I wanted to get a grasp on things, on this new part of the industry before I start releasing some videos. When I can. A lot of our customers don't really appreciate the whole video thing, so I may just throw in some videos just kind of showing some big stuff because it's interesting to me, explaining it. And I know there are some pretty smart guys out there watching, so I don't know. I can show you guys some stuff and you can explain it to me like this. I just learned about these the other day. Our low water level switches. Yeah, it's cool stuff, man. It really is cool stuff. You know, actually, let me flip this camera around and show you some of this stuff. Yeah, look over here. We got a big giant compressor. Not real sure what that is. That looks like a water pump of some sort. So maybe a pressure tank, maybe a storage tank. Yeah, not sure. Hey, if you guys know, leave a comment below. Some sort of steam something. I figured that out because it says steam right there, so you know, that makes me kind of smart. This old decommissioned boiler right here. I swear this thing's straight out of the 60s. Maybe 62, I think somebody said before. Hot oil. That reminds me, I gotta go in for a massage pretty soon. So anyway, guys, that's what I've been up to. Hope you guys have been good. It's good to see you again. I will be back shortly with some new material, all right, guys? So stick around. All right, guys. This is our awesome project of the day. This little Resner hanging utility heater, right? Nothing too crazy. The other day, we had this little inducer motor running and it was rattling. It was really bad. Kind of getting hot, seized up on us, all that fun stuff. But today, we came back and we replaced it. And I am going to show you guys something funky if I can try to do this with one hand here. Oh, careful now. All right, I'm pretty much on a decent ground, right? So, see 120 volts, right, on my meter? Right, okay. Now I have apparently developed some sort of mutant ability to absorb electricity, or we have ghost voltage, which I've only seen this, well, this will be the second time in my entire career that we have some sort of ghost voltage. Now I did check my neutrals, everything's fine. I guess just to prove that I don't have mutant powers, let's just disconnect this known working motor. That's important to say, this known working motor, right? Motor's not moving. Is that awesome? Now, this switch over here, up on the wall where it's connected to, kind of a funky switch. Let me climb up here. I'm 37 feet in the air. So that's our Siemens switch. Reset, press down firmly. Now, I've been pushing down on this as much as I can. It hasn't been resetting. Now, the first time, of course, I didn't just leave the bare wire hanging out while I was playing with the switch because that would have been irresponsible. So I don't know if we have a bad switch. I do have power coming up from the breaker box on this wire right there. So we're about to go pull the panel and do a little bit more investigating, because we could just have a breaker that wanted to trip but didn't trip all the way, or we could have a bad breaker with, I don't know, maybe carbon tracking. I'm not an expert on ghost voltage. Also, my meter isn't an expert on ghost voltage because it's not low impedance. So it's kind of stupid. So we're gonna go pull the panel and see if we can come up with anything, but yeah, we got nothing. All right guys, so this is what I'm gonna do here. I got the motor wired directly to my incoming power and this funky weird switch over here. I'm pretty sure it just hasn't reset, or it is somehow damaged on the inside and is incapable of resetting. I'm gonna bypass it. I'm just gonna put a jumper across it and see if this motor comes on. It's gonna be very hard to do with one hand. All right guys, so I got one side of the jumper hooked up to the side of the switch that goes down into the whip, into the motor. I'm just gonna touch this side to the other wire, which is coming back from the breaker. So that definitively tells me that switch is bad. So we're just gonna throw in a switch on there. And when I get that switch off there, I'm gonna open it up and see if we can see what went wrong with it. All right guys, I was gonna try to do something cool and open up the switch slowly so you could sort of see the insides a little bit better in a somewhat functioning condition, but it just fell apart in my hand. So I really don't know which part of the switch has failed. Whatever resets it though is what must have failed. I don't know, I've never seen a switch like this before, so all you smart guys in the comments can let me know exactly what this switch is and why someone would need one. I mean, I'm hooked to a breaker. The breaker will trip if anything happens. I guess this is just a secondary, a safety backup, I suppose. Who knows? So all I did was just replace it with a standard 20 amp single pole on off switch. Nothing too crazy. I'm gonna have to relabel it because it was labeled wrong. The breaker that I thought it was wasn't, although the actual breaker that it was still wasn't tripped. So our problem was 100% inside that switch. So I'm gonna go into our EMS real quick. We gotta power it up so our relay right there will energize and give us a call for heat. In the meantime, we can turn that on and make sure we have power to the board. Green light, that's good. All right, let's go turn on the energy management system. All right, guys, so this little heater has been nothing but problematic today. So we suspected a bad pressure switch, and then we eventually narrowed it down to this little fitting right here is obstructed in some way. So we take a little wire, which you can get like torch tip cleaners. That's what I normally use, but I had this laying around, but yeah, it's just not going through there. I don't know if you can see on the back side there. Let's go right over here. Kind of. Right there, you can almost see how badly obstructed it is, so we're gonna just pull it off and clean it. Right. There. Now we got it all cleaned out. It looked to be just maybe mineral deposits or corrosion of some sort, but yeah. So let's put her back together and see if she fires up now. How you turn a switch on. Boom. It's kind of rattly, I know. We haven't got that far yet. We have ignition. Hey, what's up guys? So it's the day after we fixed this little heater right here. I was just doing a follow-up with it. Everything's still fine, so no continuing issues. I did want to add this little clip just for a little bit of context. The rattling noise we were hearing in the other clip was just the little 5/16 screws they have holding that inducer motor in place to the, what you call it, like the blower housing. It had just gotten loose. The screws were just kind of stripped out, so I just put some 3/8 in there, a little bit bigger. Got it nice and tight, got rid of the rattle. But I wanted to also let you guys know, I'm gonna link probably up here in the corner or down here in the corner. I'll put a link to some other videos that I have sort of explaining ghost voltage a little bit better. I've only ran into this one other time, and to me it's a super interesting concept, this ghost voltage, how you can measure voltage and it'll trip you up, but you actually won't have real voltage there, or at least you don't have anything that can do any work. There's no current going to it that can do any work. That's why obviously the motors don't go and why you don't get electrocuted. So I'll link that up. But yeah, in the meantime guys, if you don't already subscribe, hit that subscribe button. Go ahead and find me on Facebook. Send me an email if you want. If you have any questions, any follow-ups, any feedback, leave it in the comments below. All right, guys, we'll see you on the next one.